Yes, sir. How far you been? Pooja, are you there? Can you hear me?
Yes, I am. I can hear you.
All right, that's good. So we'll get started.
Perfect.
You guys see it clearly? We just need a little- Okay. All right, so we're gonna get started. This is the course around the Agile Business Analyst Workshop. What you're gonna see it in the industry as you go through it is a lot of the way that the information was collected to build the software development has been shifting it, and the business analyst usually plays a key role into it. Okay, so typically, like it's this course, Harshal and I kind of team up to teach a whole bunch of a few courses. I think it's all of you had an opportunity to meet the Harshal. It's kind of we focus on like it's building the course based on the experience that we have it in the real world to do the same work type of things. So Harshal has been like it's he and I go back almost 30 years.
Yeah, since
Right.
94, 95, I think, yeah.
Yeah, so almost 27, 28 years.
Yeah.
And then like he has been like it's kind of focused on the whole entire software development lifecycle. And he's been kind of like it's working as an independent consultant for so many years, right?
Yeah,
With all the
since
different
1995,
clients,
so, yeah.
all the different clients and so
Yeah.
on. But essentially, like he has seen the whole development life cycle, going it from the planning the project to analyzing it to building it and executing it. Okay.
So let me talk about Dilip, so as Dilip said, right, Dilip was in the Wright State University doing his master's. I was in Dayton, University of Dayton, doing my MBA back in 90s, I think 94, 95 timeframe. So I mean, but he's in IT since then. He had a bachelor's in electrical
Electronics.
electronics engineering, and then he did the master's here. But essentially, he taught for a number of years as well at Franklin University as a faculty for almost like 10 years. And but now he's at JP Morgan right now, which is a fairly large company. I mean, here. And he leads Agile transformation for them. So he knows inside out about SDLC, Agile, and plus in the prior roles, he has worked various roles. I mean, he started QA, BA, he did architecture, a lot of different things. So anything that you can throw at him, he'll be able to answer. And those things.
So let's talk briefly about all of you, right? So what I want to do it is it's get a little bit know, as Harshal said, like he knows everybody's name off the top of it. And I'm one of those who usually takes 2 or 3 sessions to remember everybody's name. But what I want to know is your name, a little bit of background. Specifically, I'm interested in any exposure you have it in any sort of analysis type of work or computer software development type of work. And then expectations, what are you looking at to get out of this course? So let's talk with you, Vanessa.
Okay, good morning, everybody. My name is Vanessa Nana. So my background, I have a bachelor in business and information technology. So I'm working right now as a customer service representative for Diamond Innovation. So my expectation, I want to know more about Agile, and my goal is for a career change.
Okay.
So I know a little bit because I got some certification,
Okay,
PSM1 certification.
PSM,
Yeah,
okay.
PSM1
okay.
certified.
Yes,
Gotcha.
I just got my certification like 2 weeks ago.
Sure.
So right now I'm trying to learn the business analyst and get into the field.
Great.
So when you said you got the PSM certification, you want to get into the Agile world, what's your goal? You want to be a Scrum Master or you want to be a business analyst?
For a long-term goal, I want to be a Scrum Master, to be honest, but I want to know everything around the product owner role, business analyst role. I'm trying to learn everything about Agile.
So have you worked on the IT projects in the past in your role, or have you dealt with any IT systems?
No,
Okay.
only when I was doing my education in.
Okay,
Yeah,
okay,
so, and it was long time ago.
I see.
Yeah,
Okay.
That sounds good. Are you related to Nana, any chance?
yeah.
There works at Nationwide.
No.
Nana, what's his name? There were a few Nanas. over
Yeah,
there.
you're gonna see a lot of nanas
Yeah.
in
It sounds like a common name in Ghana?
Ghana and Cameroon because I'm
Cameroon,
from
okay.
Cameroon.
You're from Cameroon, okay,
Yeah.
gotcha.
So it's kind of interesting that you mentioned about Scrum Master. In fact, like it's a chase, as I also run it. I actually like it's also run a long duration programs to actually do the Scrum Masters and get the product owners. I'm starting another one on a Monday morning.
Oh, really?
So it's typically a 3-month program that I run there.
Oh, really?
And that. So
Okay, great.
I'll be interested to say let's go through it.
Yeah.
So- Geeta, what about you?
Yeah, my name is Geeta Kapoor. I did my MBA in marketing and human resource from India only. Currently, I'm working with Safe Flight Solutions as a CSR, customer
Okay.
service representative. We just got our process changed. I was a claim adjuster. I did
Okay.
1.5 years for all the insurance companies, like for the auto accidents.
Sure,
Mhm.
And before that, I worked for a few motels here.
okay.
And I was managing those motels, and then I worked for New York Life Insurance Company as
Ah.
well.
I see.
Because my background in India was insurance only. I was selling life insurance. I did banking, credit cards, FDs, all that background, and that's it.
So
That's
yeah,
great.
so you will be able to relate a lot of things as we go through it because of your background.
Hmm.
You've seen different processes and think about it, how we, as we go through the analysis process, how that business domain plays a key role into it. So
I
what are you
joined
expecting
QA
out of it?
I joined QA a few years back, but
Okay.
at that moment I was managing one motel, so I was not able to learn just because that I was doing my job on. So I quit. I mean, I missed few classes, so I did not understand
I
anything.
see.
This time I really bond that because I think QA is difficult for us because we don't have that background. So maybe in business analyst. So I should get a good job maybe, yeah.
I mean, nothing is difficult, okay, as long as you learn the right thing in the right way, I think, and you get to do hands-on.
At
Yeah,
that
then you
time,
can-
I
yeah.
did not take it
Sure,
seriously,
I
so that was
understand,
my
understand.
fault maybe, yeah.
Yep. No, I mean, it's completely, and I think I think Rati and Kashmir, you work with
Rati and me was in the
Okay.
same job,
Okay,
but I don't know Kashmir actually.
Kashmir,
Okay.
okay, I see.
Yeah, I think it was here, what, like 3 or 4 weeks ago.
Yeah,
Right, one of the things.
yep, that's good.
All right. So Pooja, online, tell me a
Yeah.
little bit about your background and expectations and experience.
So I did my MBA in HR back in India, I think in the year 2015, I passed out. And from 2012, so that means the last 10 years, I have been into the education industry where my two major roles were one, dealing with the entire sales team, and the other one was completely into teaching and creating content.
And
So
then what was the
after,
topic?
sorry?
What was the topics when you say you were in education field? What kind of content you create?
So when it came to teaching, I was into three different exams. One was all the entrance exams for MBA back in India. So, CAT, CET and all of that. And the other thing was GMAT, GRE.
Okay.
So, yeah, so verbal aptitude and logical reasoning under all of these exams.
Mhm.
So, yeah, so last year we came to Canada, and from the last 6 months, I have been working with CIBC here as a financial services representative. Pretty happy with the role as of now, but I did feel the need. So, once I came here and I entered the industry, I very soon understood that here you need to upgrade yourself very quickly. We can't be waiting for, the promotions and for the employers to come to us. So that's the whole intention of learning as many things as I get interested in.
So it's kind of interesting that you mentioned it. Is one of the things that you got to get used to it is constantly updating your skills and learning it. It doesn't matter whether you're a BA, QA, software engineer, or architect. Because it changes so often and technology changes so often. As we go through it, we'll talk about one of the case study that we'll do it. It's essentially centered around the change in the business model that requires a change in the technology. And then that also forces us, all of us as an individual, to constantly upgrade it. I would say it's that even with this many years of experience, I typically spend an hour or so every day just kind of reading through it, or like it's even at the work learning through new things.
Mm-hmm.
So that's something that, just like it's whether you're in the medical field, you're probably going to do the same thing in the IT field. It's constantly updating yourself because the technology is moving so quickly. And the whole model around how the people and the products are built is completely changed on its head within the just last 10 years. Okay. So let's talk about it. Like it's when Herschel and I started building, this series of training courses, right? For the BA one, what we are talking about is making sure the students who go through this course understand what it means to do a requirement management. Also understand the role that the business analyst plays in overall software development. And then the techniques to define, analyze, and come out with the requirements. Now, again, as we go through it, we're going to talk about the different software model. Doesn't matter which model or techniques you use it, you're still going to do the similar practices in order to analyze the requirements. Okay, so let's get started. The more that you're going to see it is today's lecture, it's going to be a much more talk at you type of lecture. What I'm going to talk about, giving you the basic background, the framework, understanding of what it means to be software development. But starting tomorrow, there will be a lot less kind of a lecture, and there will be a lot more interactions and actually doing the activities that you will do it a normal day-to-day in the business analysis. Okay. What typically we're going to go, it's every day in terms of Saturdays, Sundays, we'll go from 9 to 1. Sometimes we'll probably finish a little bit early, depending on where the logical break is for our content. And then we'll probably take a break every hour and a half or so you can stretch your legs. In terms of that, we have water here, as well as like if you want to, there's a restroom right here on the right side. And then every Thursday, we will have what we call it is a more like a lab session. So we'll give you some additional work that give you time to think about it and build it. And then we'll review that on Thursday and have any more conversation around if you have any questions or doubts and so on. One of the key other thing that you also have to do it is like it's Sangeeta, you pointed it out, is as you go through the 4 weeks, don't think about only the activities you're going to do only in the classroom, right? We will give you some homework that makes you think about whether it's reading it, writing it, or coming it up with things. And it's critical because the more you will practice it, the more your knowledge in the lesson will stick in. So there's like research and studies that like if you don't continue to practice what you learned it, you typically lose with 90% of that within 60 days. So that's part of the reason why we want you to practice it so that you catch it up and then continue to practice it. And we'll talk about some of the tools as we go through it too. Okay.
Okay.
All right.
Sounds good. So I'll let Dilip work with you. But I'll be back probably maybe around 10:30 minutes. And so we can work together. Okay. All right, and I think those two guys are running real late, so we'll remind them.
Well,
Make sure
we are recording it so they can just listen to it.
Sounds.
Thank you.
All right. So the way I want to like it to work is as I go through it, if you have any questions, stop me. Like, there's no point in going through it. So in your folder, you should have all the slides. So feel free to make any notes. Those are your folders. And Pooja, you should have that shared by Herschel. So you should be able to pull it up online and then just work through that.
Okay.
Okay. So let's talk through it. What is a software? Okay. So since the activity that we're talking about is analyzing the business requirements and the role for building a software, let's first understand what is the software and the whole history around it and the different architectures so that we can focus on, as we go through it, more discussion and case studies. You have that thing as a background back of your mind so that we can talk through it. Okay. So when you consider a software, in my mind, it's nothing but a simple sets of instructions that you give it to any computing devices that they can just produce a specific output. Okay. So think about it like it's, if you are cooking, right? And if you get a recipe, what is a recipe? Recipe is nothing but step-by-step instruction, right? And you as think about a processor, take that step-by-step instructions and then produce it like it's operated so that you can get the food created, right? Think about computer is the same thing. It is just create a step-by-step instruction and then you pass through computer and it'll create the desired output or product that you're looking for. Okay. And so let's talk through it. Why do you like it's want to learn about it? Right? So like it's when you look in today's world, doesn't matter what you look at, where you look at it, there is always software and computer around it, right? Like it's all of us or majority of us are hooked up on the phones. Nothing but a software, right? It's computer, just that it's a mobile devices, right? If you're trying to like it's take it any pictures, right? And then trying to do processing on those pictures, it's nothing but a software. In fact, most of the picture stuff that you take it now are digital cameras, right? But then you take a DSLR, no, they're nothing but a computer. Everything is just processing with the software inside it. Be it like it's when you play video games. Those are software. My favorite one that a lot of people kind of end up using it at this time of the year is the income tax software, right? You don't have a choice but to go through it to pay Uncle Sam their money. So think about it is when you talk about a software, it's essentially a computer program with a step-by-step instruction that tells you what to do it. Okay. And then at a broad category, you can break it down the software into two categories. One is a system software and one is application software. Let me see. Two. Just gonna I'll just run it in this one. So. Okay. So I want you to think about what happens. Give me a second. My screen is not coming. Pooja, we're running into some technical difficulties. Give me a second. Try to see it why. The
Yeah.
monitor went blank here in the classroom. All right. So we're back. So whenever you think about any computer systems, think about it as a box. Okay. Think about it as kind of three different layers. Okay. So think of three different layers. Okay. The most bottom layer is a lot of times known as a hardware. Okay. This is actually touch and feel. So if I think about a phone, right? So this is actually the hardware that I can touch and play with it. On top of it, they usually have something known as a system software. Okay. So these are the piece of software that actually controls the hardware. Okay. So if you're using an iPhone, right? Your iOS is the operating system, it's just system software. If you're using any of the Google or Android devices, Android is the operating system. Right, so whether like you're using things like Nokia or Samsung or any other non-Apple devices, right? Typically they're on an Android system. So just one second. Yeah, sure. Okay. Okay, let me check. Okay, bye. Give me a second. I think yeah, but they all can get into it.
will share our numbers, phone numbers.
Hmm?
I said we will share our phone numbers.
Yeah, we will do that.
Later in the class.
Yeah. During the part.
Plan to be here at 9 tomorrow. You're very late. How are you? So your iOS and Android acts as system software. And the layer on top of it is known as an application software. Okay. So think about it like it's, let's take an example, right? When you want to like, it's actually, let's say, want to send somebody a text message from a phone. Okay. So what you're going to see it is you're going to open up probably an application which allows you to send a text message, right? That's an application software. It allows you to do something of productivity. Okay. So you put it, the number where you want to send the text to it, and you put the actual content of the text. Okay. And then you click the send. What happens at that point is the application software communicates with the system software and says, hey, I want to do this particular function. Okay. System software then actually takes that information and converts that number, the SMS number, and the text into telling the hardware, hey, you need to send a message to this number. And the hardware then actually creates the Wi-Fi waves, right? The signals that will send it, and every signal will have specific information encoded into it, which will kind of go and says. Okay.
So I'm gonna take an example.
Mhm.
If I have like a computer, right? For me, I was thinking about the hardware can be like multiple, all the part inside the computer. Is that correct?
That's the hardware, yeah. Anything that you can touch and feel,
Okay.
it's
so,
the hardware.
like if you open the multiple, all the part is the
Yeah,
hardware.
this, like it's if I'm using this laptop,
Mhm.
like when I touch it, this is the hardware.
Okay, so now the difference between the system software and the application software that.
Okay, so think about you having a hardware, okay? So let's take an example of Windows machine, right? The laptop. Are you familiar with that?
Yeah.
Right? So just because you have a laptop and you want to use a Microsoft Office on it, you can't just simply say, hey, I'm going to turn on the laptop and we're going to have Microsoft Office. Like you need a Windows, which is an operating system, right? Windows essentially controls how it interacts with the hardware, right? So take another example. If you're driving a car, right? You have a dashboard on it for the radio, right? So actual hardware is the radio itself.
Okay.
On top of it, you have some sort of operating system or some sort of system software that essentially allows you to tune it into whatever the air frequency or wave is, whether FM station, AM station, or NHD radios, right?
So is any system that help you to maybe get into something?
Anything that controls the hardware of how to operate the hardware. Okay. That's what it is, a system software is.
Okay.
So let's say Excel, Word is application software.
Right. So anything which is, hey, I add on top of it to perform productivity tasks is an application software. Right. In order for me to run
So please, I have a
anything.
question. So in this case, that means maybe the radio, the thing that you tune to increase the volume,
That's all hardware.
oh, they are hardware. And the system software is what's inside there.
Right. What controls that hardware?
Okay.
So a lot of times you will hear that like it's the term that used for the bottom two layer is the compute platform. So think about it, right? When you use the iPhone, like you may have an iOS. Okay. Sorry, Herschel is trying to get me. So when you think about an iPhone, right? And let's say, let's make you want to do an email, right? You're gonna have an email as an application on top of it, right? But you cannot be that successful unless you have an iOS uploaded on there, right? So when you get the device out of the box, right? You may not have that application loaded into it, but you will have an iOS loaded into it, because without that, you can't do any connection, right? You can't figure it out the SIM card and that. So think of that as anything that I needed in order to work that hardware, it's going to be part of my system software. Then anything on top of it, which will be my productivity software, whether it's like my email system or a text messaging system, right? Or even Safari browser that I get it on the iOS, or the Chrome browser that I get into my Android devices, they're nothing but an application software. So it's something that you can remove it without impacting the platform, or you can add it without impacting the platform. Okay. About, I would say it's 99.99% of the time. So when you go out in the world as a business analyst, you're going to be playing only in the application software space. There's not many companies which make the system software. There's some dedicated, right? Like for example, if you like to do a Tesla, right? Now everything in there to operate your car itself is a system software, right? But then you can also add then mapping, right? So Tesla allows you, hey, I want to go from here to here, map it out route where it finds it, where my power charging stations are, and everything else. That's an application software on top of it. But in order to do a self-driving and all, that's a system software. Okay, so think about that. Whenever anybody talks about the computer systems, these are three fundamental components of how the computer systems are made. Okay, and most of the work that we're going to do it is always going to be focused on application software. Okay. Hardware is obviously requires a lot more engineering. So whether you're a computer hardware engineer or electronics engineers, that you build it, all the chips and manufacturing happens here. And the system software is essentially like it goes in to manage this hardware. And it's typically done through what is known as a firmware, but you guys don't need to worry about that. Okay. And then hardware. So essentially, when you think about it, right, any communication, your application software does it, never does it directly with the hardware. It always goes through the system software in order to communicate it. Okay. Any questions on these things? Okay. So we talked about, right, the computer systems platform, right? We talked about the bottom two layer. It's the system configuration and system software. Right. Then we talked about the application software, right? So typically most of the things that you interacted, like I said earlier, we talked about whether it's a text software or photo processing software or anything else that we talked about, like video games, all of them are nothing but an example of application software. It runs on top of it. And so think about it, right? You might have interacted with any of the gaming consoles, right? So gaming consoles is nothing but a combination of system software and the hardware. And then you buy a game and download, either play it from the internet, or you buy the actual DVDs and then you plug it in and then you play it. So think about that. That particular gaming console and interface itself is a hardware and a computer platform. And anything on top of it, when you play a specific game, those are the kind of application software. In olden days, the perfect example was, hey, anything that you attach it from a hard drive or a CD or a DVD-ROM, those are going to be an application software. Nowadays, everything is on the internet. So anything that you download it, that you need to go through it. Like for example, Microsoft Office 365, right? It's a perfect example. You go to the cloud, or anything that you do it in the email world that happens sit in the cloud. They are nothing but an application software. Okay. And the goal for the application software is essentially allow you to like it's have a productivity. Right. So any business problem that you're trying to like solve it is always going to be in the application software domain. And that's where we're going to focus it in the business analysis bootcamp. Okay. Now, let's talk about the different types of application software. So depending on where the intellectual property lies and how you utilize that, you can divide the application software into one of the three categories. Okay. The first one is a proprietary software. Okay. It's essentially a one kind of a program or a software application that's kind of usually built, developed, and owned by one company only. Okay. So I gave you earlier an example of Tesla. Right. So when Tesla builds a automatic car driving software, it essentially allows you to do a essentially self-driving car. You can't take that software and put into your GM car and expect it to work, right? Because that is designed specifically for Tesla, and it's all of the intellectual property is owned by Tesla, right? You can't just take it, hack it, let me get the software and put it into there. You can't, because all of the essentially you can buy it only from Tesla for that particular purposes, and you can install only not as an individual, but also along with the car itself. Okay. Another example is all of your iOS devices or Apple devices. You can take a software that Apple has designed and build it to run on top of iOS and take it onto Windows device or a Samsung device to run through it. So that's an example of a proprietary software. It will design and execute only on certain hardware and it's owned by only certain group of people. The second set of application software is going to be off-the-shelf software. This is the program, even though kind of owned by a single company, it's designed to run on a multiple hardware or multiple platforms. Okay, so I'll take an example of Microsoft Office. You can take Microsoft Office and run on Windows platform. You can actually take it on another version of the same Microsoft Office, and you can actually install it on the Apple devices or MacBooks and use it. Video games, right? We talked about that. Hey, I can download it from the internet, and I can run it whether it's an iOS platform or it is on the Android platform. Another good example there is tech software, right? If I go today at Best Buy and buy a tech software, let's say I buy a TurboTax, right? I can actually install it either on the MacBook or I can install it on Windows and it'll still work the same way. So that's an example of off-the-shelf software. So hey, I can pick it up something from the shelf and use it across multiple platforms and it will still work as expected. And the third piece of application software is open source software. Okay, these are the software which is actually developed by a community of developers or built by a company, and then they give it out in the community. So you can use it for free under certain conditions, and you don't have to pay for that software. So it's kind of free for you to use it. So that's why it's called an open source. You can take that software. If you like it, you can modify under certain rules or license agreement, and then you can use that modified version for you. Okay. So when you go into software world, right? So a lot of programming languages are kind of now gearing towards becoming an open source software. So you'll hear a word called Java programming language. That's nothing but an open source. Perfect example is Android operating systems on the mobile devices. Okay, Google has built it, put it in the open source. So if I want it, I can actually down the Android operating systems and put into my tablet, even though the tablet may have been originally designed for Windows. Okay, and I don't have to pay a license to Google for downloading and updating my device with Android. Okay, so anything that is kind of given it as an open source. But now when you go try to like say, hey, I want a full support on it. Hey, I'm having this problem and I downloaded this particular volume button doesn't work it on my tablet anymore. That's not support that you get it from the Google, right? That's something that, hey, you did, you have to figure out what the issues are. Okay, so that's the 3 different types of application software. Any questions?
So for the last one, you said example is Android, and can Windows be still the example?
Windows is not an open source. Windows is owned by Microsoft. And if you want to install it, you need to buy a license. You have to pay for it.
Okay, so the only example for the open source software is Android?
It's one of the examples. There are a lot of others in the development world. For example, Linux operating system, it's an open source.
Okay.
Like it's, if you go into high-end computing, like it's all of the Facebook, or now it's kind of called Meta, all of the data center management is kind of open source. Think about it, like Facebook manages over 1 billion users at any given point across their global network. All of that software that manages that entire distribution and send you the, hey, there is a message or there is a Facebook feed and all, it's all open source. Right. Some software, it's easy to understand it, open source. Some are going to be complex. Okay. Any questions on this one before we move into the software architecture world?
So the off-the-shelf software, you have to pay it, and the open source not.
Yeah, so the open source is free for you to use it, but it's only for you. You can't just go and say, hey, I'm going to take that free open source software and I'm going to sell it to the people. You can't. There is a certain license agreement. You can sell services around it, right? You can say, hey, you know what? I'll help you to download and install this open source software, and I'll charge for the services, but you cannot charge for the software. Okay. Vijay, do you have any questions, or you're good with that?
No, so far so good.
Okay. All right. So that's about the software, right? Now, let's talk about another dimension, right? Software, it's essentially, it's nothing but an activity that you need to build it around, right? So whenever you talk about building anything, the things comes around architecture, right? So let's talk about the home, right? So let's say if I want to build a house. The house is going to be built of multiple components, right? It's going to have my framework, right, which essentially foundation frame. It's going to hold the house. And I'm going to have an electrical systems. I have plumbing systems. And I will probably have a air circulation systems, right? So I'm going to have multiple components in the house. And then the way that the blueprint works it is essentially figures out, hey, how are these different components? It's going to work together to perform as a one single unit so people can live in the house. Right? Think about computer software is the same thing. When you talk about an architecture of a computer software, architecture is nothing but essentially a view of how that particular thing is broken down into multiple components, where each component has specific functionality and it has specific characteristics and a relationship with the other components. Okay. So when I build an air circulation system in a house, right, think about it, everything runs on electricity, right? So while the air circulation system is kind of independent, it just goes and, hey, I'm gonna like, it's kind of get the used air out through the return vents, and I'm gonna force the fresh air from the vents that are the main vents going into the house, right? That's circulation. Oh, by the way, I'm gonna cool it or heat it up depending on the weather and that. But in order to do that, I need some sort of electricity, right? Whether it's a gas or electricity, it's still the same thing. So there's going to be some interface, right? So while the air circulation system is still working independently, it is going to have an interface with the electrical system. And it's going to have specific, right? You can't just go and pick and choose whatever you want, right? There's always specification, right? Hey, if you're putting in this much unit, well, you need this much type of capacity, you need this much power, right? Or if you're putting the gas heating element, then you need it like it's a converter that essentially allows you to convert your natural gas into electrical, which then generates the thermal heat, right? So think about that as an interface. Same in a computer world, right? We talked about the system software and an application software, right? So if I build an application software, it needs to know how to interface with the system software. Even within these application software, right? I may have a multiple component. So if I go into any of, like it's all of you interacted with some sort of website, right? So let's say if I go into Amazon's website, right? Amazon has the entire software, which essentially allows you to look at the products, order the products, pay for the products, and ship for the product, right? So all those things are nothing but a different component that they are working together, and they have a specific interface. So that's when you bring it all together, that becomes a system architecture or software architecture. Okay. And there is a specific relationship between that, and then that's what you define it. Okay. Any question on the broader level, what architecture means? Now let's talk on the software architecture. Okay. So now that you know the architecture is nothing but a components and the relationship between those components and the properties about those components together. Okay, let's look at it, how the software has evolved. It's almost now, I think it's close to 80 plus years that the software is in existence. Okay, and over the 80 years, the architecture has been evolved of the software. Just like when you think about the home, right? So if I kind of like look at over the human history, like the way the houses were built, let's say in the 1100s, it's going to be different than the way the houses were built in 15th century, then the way the house was built in 20th century, and now the way the houses are built today are different, right? Things were evolved. The more you learn it, the more you evolve it and do that. Same thing with the software world. However, just when you look around the world, right, there are still houses exist, which are 50, 60, 80, 100, 200-year-old, right? And then you still have to do the maintenance, you still have to interact with that. Same way with the software world, even though in the last 80 years, the software has evolved a lot, you will still going to see all those architectures. So let's talk and take a quick look at the different architectures. And a lot of the way that you grab the requirements and you try to do the need of the user for the software essentially also drives the need around the architecture. Okay, so let's take an example. In the original computer, when they were built, they essentially like everything was in a single unit. Okay, it was kind of a big monolithic. So when you look at the any software, right? It consists of two components. One is telling you what is the instructions. In other words, what do I need to do it? And the second set is going to be the data, which is essentially what is the input. So let's take an example, right? If you use a calculator, calculator is the simplest machine, right? So when you do a calculator, there are two pieces of it, right? One is, hey, I know how to calculate like it's 2 plus 2. But that requires an input, right? The data. My data is 2, the operation, and the 2, right? And then it will produce an output. So everything that you do in a computer world, it's gonna have two pieces, right? One is things that talks about the execution in terms of what are the transformation I need to perform. In the data, which data I'm transforming and what the output data is going to be. So I'm kind of like, it's a little bit of space engineers, right? So when you look at it, today's world, right? Let's say humans are working to go to the Mars, right? So like it's, as you like, it's kind of send a rocket from Earth to Mars, right? The further you go, the longer is the communication delay. Okay. So when you go to the Mars and you're trying to like it's land either a rover or something on the ground, right? It takes it only like 6 minutes from that's Mars atmosphere to reach to the ground. Okay, but it takes it a 16-minute round trip if you're trying to send a signal to that particular rocket from Earth to the Mars. Okay, so if you kind of like just assume, hey, I'm going to communicate every time, see what it is, I'm going to make a course adjustment before I land it, right? By the time you get the round trip message, that lander is already crash landed and it's burned up, right? So they have to build a systems. So in most of the rockets, you're going to have what is known as autonomous system, where it's not relying on external things. Your code and data, it's everything is right there. They get the data, they process it, they make a decision, and they continue processing it. Right? Same thing with the cars, right? When you talk about the cars, right? When you do a, let's say, adaptive cruise control, right? So you guys know what adaptive cruise control is, right? So when you are sitting in a car and you're putting in a cruise mode, right? And you're going in the traffic, let's say I'm going on a freeway, and I put my car to be a 60 miles an hour on the cruise control. And as the traffic slows in, right? The car in front of me slows in, your adaptive cruise control will automatically hit the brake because it recognizes the car in front of you has slowed down, right? There's no intervention, there's nothing, not going anywhere, right? It's the code and that, so they automatically detect it, operate it, and make a decision and do that. Okay. So that's what the monolithic application is. Everything is in one place. I'm not doing it anything too separate. Okay. So another, like it's an example. Have you guys, anyone of you have watched a movie called Enigma? Okay. So whenever you get it, like it's if you're interested in the science, look at that movie.
What's the name of the movie?
Enigma.
Okay.
Okay. So it's a movie around the Second World War. So Germans were using a code system to send the communication to all of their field units, right? And the Allied forces are trying to like intercept those messages and try to interpret what those messages are. And so that they can take corrective actions, right? Specifically the U-boats, which was German submarines, kind of creating a havoc on all the navies that the Allied forces had, right? So the movie is about a scientist called Alan Turner, which essentially uses a computer to take that message and break that code. So that's what the movie is about. The reason I want you to think about and watch the movie, it's a perfect example of monolithic application. Okay, so they get the message, they actually go to a big room, right? The original machine was like, it's kind of 10 rooms big. They put manually the entire message coded into the machine, and they will let it run for 24 hours before it can spit it out. What is the decoded message is meant to. Okay, so that's all monolithic. They just load the data along with the whole machine, and then that's what it is. So that's what that. This was also the original calculator when IBM built it back in 1930s. It was a one big machine, a one big room, and that's the computer. You can't go use it for somewhere else. You have to go to that room, enter the calculator data, and then do it. versus now in today's world, you have calculator all over the places. Okay. So as the computers evolved, they started seeing the value of what it can do. Okay. So the commercial world, they started looking into it and says, how can I have more people use that computer? That's a significant investment. Like when you look into 1940s and 1950s, computers will cost $1 million plus. Okay. So they evolved into an architecture known as a client server architecture. Okay. So the thought behind that is, hey, you know what? Most of the computing or most of the processing power can be at center. And typically, like it's kind of, when you weight it, that processing power is eventually coming in faster than you needed one person's request, right? It's taking it person to put in more information a lot more slower than what computer can respond to. So they said, hey, why don't we can start having multiple people use that computer? So that's when the client server architecture came in. So in this mode, they have a big server, right? And then that big server is connected to multiple clients and take a request from those clients and send back the response. Okay, but as you kind of evolve this architecture, it adds a complexity, right? Here, there's no complexity, right? I have only one set of code, one set of data, and that's all I'm doing. I don't have to worry about it. Here, I have to worry about, hey, what if client one sends the request? I need to make sure the response goes back to that client. And I compute the response based on that request, right? Same thing for client 2, same thing for client 3. Think about banking. Right? That's what this and insurance companies that started for the claiming and all. If I'm a bank, right, and I'm asking you to deposit my money, you don't want a computer to go ahead and deposit in somebody else's account, right? How many of you want to do that? Right? So the complexity involves it, right? So now when you look into the requirements of, hey, I need to build a software to support this kind of model, now I need to start wording a little bit more complex than what I was doing in monolithic code. Same thing for testing, right? If I'm a user, I want to make sure I test the scenario where multiple people put the request and I get it the right response every time to the right person. I also have to worry about now, what if the network over which this client is connected to server is broken after the request is made? What happens to the response? When I reconnect it, do I get the response back? I don't want it specifically when I'm doing the payment to have it go through multiple times just because it lost the internet connection. I don't want that money to be taken out multiple times from my account. Right? So that adds a complexity. So think about that, right? So as the architecture evolved, you got a flexibility, but then you also had a complexity added to that flexibility. Then as things evolved, right, as the computer started becoming more and more popular and more useful in the corporate world, right, they started realizing that it's not just a simple server and a client. Okay. What is the most important asset in a corporation? What do you think its most important assets?
Security.
Security is kind of not necessarily asset, but it's something how I do the things. But the most important asset is the data. It's the information about your customers, right? Because if you don't have customers, you don't have anything else in terms of sales, revenue, protection, whatever you need, right? You don't exist. So the most important thing is to protect the data. Right? That's why you see it when you mentioned about security. One of the key things is that why there is security, because there is a need to protect the data. Right? So as more and more organizations started using computers, they started understanding that data is the key assets. Right? However, there is also another aspect they started thinking about it, right? So let's say if I'm a bank, right? The way I kind of operate a deposit for one customer is the same thing as how I do a deposit for another customer, right? Same thing as like it's, hey, I want to check the balance. Doesn't matter who the customers are, right? Checking the balance, the process is still the same, right? So they started breaking it down and says, hey, wait a minute, we don't need a one big server, which contains both the code and the data, right? Because that's what it was, right? So when you look at this was code and data into one place. This was still code and data into one place, right? It's just the request was coming from different. But now they started realizing that, hey, you know what? I can manage my data separate, and I can manage my code, or which is the applications, separate. So they started breaking it down, the server or systems, further into two components. Here's my data, which is the most important, right? How many customers you have it, what their account number, how much deposit they have it, what other kind of products and services they're using it. Versus how do I check the balance? How do I kind of add deposit? How do I withdraw the money? How do I do bill pay? Right. So that became an application here. Okay. So this is where all of your business rules and business conditions are going to be stored. This is where your actual customer data is going to be stored. Okay. And your application operates on the data. Now, one of the other things which started happening in early 80s is you're going to have more devices. So you can go like it's from a banking days. Let's say if I take a banking application, right? You can walk to a banker, wherever they have a branch, and then do that, right? And then you all have a tailor. The tailor is going to have a different interface, right? Versus I can log in from my home and can do it online banking from my this, right? Still, check my balance should return the same result. Just because I went to a branch, it should not give me a different result than when I log in into it. But my interface is going to be different, right? So they broke it down and say, hey, application here is the business logic, but how the information is presented needs to be separate and goes into the presentation here. So now your simple architecture is kind of started evolving into multiple layers. Okay. So if I'm a business analyst, right, I have to now worry about, hey, what is the presentation related requirements? Oh, by the way, that's going to be dependent on which device or which location the people are going to log in from. What is my application or business rules requirements? What is my requirement to protect the data or manage the data or manipulate the data? Right. So now when you're looking at the business analyst, you have to start breaking into it. Oh, you know what? Now my requirement has to cover this area, and this area too. Which earlier was not the case, right? Because everybody had the same interface. So all I have to worry about, hey, what is the single common interface? Okay. You guys good with this so far? Then came 1990s, came internet. Okay. And the things like Amazon started evolving it, the e-commerce retailer, where the number of customers are massive. So till 80s or even early 90s, right? Since there was no internet, right? Your scale is, I will physically go to the building, right? And I'll interact it. Well, what is my outlet, right? So if I'm a big bank, right? And I have 500 branches and each branch has 3 tailors, my scope is only I have to deal with 1,500 tailors or 1,500 transactions coming at any given point, right? Same thing for if I have a Barnes and Noble, I have a physical bookstores, right? And I have 4 checkout machines to serve the customer so that we can purchase the book or whatever the item they're looking for it. And I have 50 stores. It's only 200 concurrent things I need to worry about. But as soon as the internet came in, the game changed, right? Let's say I had 100,000 customers, Earlier, they had forced to come into the store and they can do it by only. But now 100,000 customers can buy things simultaneously. So instead of worrying about only 200 people or 200 connections coming to my computer, managing the data, managing the application, I have to all of a sudden now worry about 100,000. Right? And as I go through it, my computer resources are still limited, right? I can't, like it's after a certain point, I cannot afford it to keep expanding. So let's briefly chat about the computer resources. Right? So when you buy a computer, right, you will see a little bit different specification in it, right? It'll say how much RAM you have, how much the solid state or a secondary storage you will have, right? And then you can essentially buy a USB drive, which is an external storage or an external drives, which allows you to expand even more the storage. Okay, so even in the corporate world, right, when they build the application and deploy on the servers, they have the same limitations. Okay, and this all boils down to how fast the information is kind of like it gets pulled into it. Okay, so let me see if I can. It's a Microsoft Pro. Trying to get the there it is. All right. So think about your traditional computer. Okay. So in traditional computer, you have something known as CPU, which is the brain of your computer, right? That's where all of the processing happens. Okay, so whenever you give it any instructions, that particular thing is the actual one which processes everything. Now, it needs a storage area, right? Where to pull the data from, whether it's a code or instructions or data, right? So typically, they have a level 2 cache on it. Okay. So this is physically on the same chip, right? So if you, I don't know if you ever kind of seen any diagram or picture of things on inside the, let's say even on a phone, forget about the computer, right? So you have the actual processing power. So when you read any specification of any computer, right, it will tell you, hey, how much is the computing processing power, right? So it'll say, hey, 8-core, 2 gigahertz processing. And say it's, let's say Intel i7, or if you're using the MacBook, it will say M1 processors. Okay. So when they say this much processing power, they're saying is how fast the CPU is processing. And then they will also have, hey, it comes with 2 megabytes of L2 cache. What it talks about is how much memory is on the same chip, physical chip. So it's right co-located. Okay. And since it's co-located, the rate at which the CPU can read and write information to that, it's in the nanoseconds, which is 10⁻⁹, right? So within a second, it can do 1 billion operations in reading and writing within that process. It's very fast, right? So if I'm trying to like it's do it, and let's say one operations was taking care of one person's request, I can take 1 billion requests right there, right? It's very fast. So then, but obviously it's only 2 megabytes, right? So when you take an average photo now, a high definition nation picture. It's anywhere between 10 to 20 megabit picture. Okay. So as they need more, they have something called a RAM, read-only memory. So when you look at the computer, the second part of the specification is going to be, hey, it has a 4 gig RAM, or it's 8 gig RAM, or 16 gig RAM. Okay. What this thing is, both of this are located on the same motherboard. Okay, so they both are right next to each other, but they are still not in the same physical. So when you do this, right, so this one, I can access 10⁻⁹ a nanosecond. This is typically 10⁶, right? So it's 1,000 times slower when I try to access the information from this. Okay. Then you have solid state drives. Okay, which is typically to say, hey, you know what, I have 512 gig of solid state, or the third number that they will give you in the computer specification. It's 1 terabyte or 4 terabytes, even on your phone, right? So when you talk about the phone, right, it's a, hey, it has a A16 processor if it's a iPhone, or it's like Samsung, it says, hey, it is an 8-core processor, right? It says it's 6 gig RAM, which is essentially the second number. And it says it can store 128 gig or 256 gig, or now it's some of the variants you can even get a 1 terabyte, right? So that's the additional storage. But this storage is not on the motherboard, it's physically separate hard drive or chip. And then if I need to access any information from that, it typically takes a millisecond. Okay. So if I have an information which is right here, which is an L2, versus an information which is in solid state, right? It's almost 1 billion times slower, or 1 million times slower, sorry, 6, right? So you can think about it, how much slowdown it's going to happen to process that information. Still, when you look at still 10⁻⁻3, it's still 1,000 instructions per second. Okay. Then they have something known as an optical drive. Right. So when I put the USB drives or a DVD or CD-ROMs, right? Those are typically 10⁻⁻² speeds. Okay. And then they have something known as offline drives. Okay. And these are typically like seconds, sometimes minutes, because I have to restore things from that and do that. Now here are all the stages of the memory, right? So when you go it from left to right, the thing slows. Okay. So your question is, hey, if this is slowing down, why not put everything into the CPU and get everything work so fast? Right? The things comes down to cost. Okay. So when you look at the here, right? So this is probably like it's the cost is less than a penny per gigabyte. Okay.
So why is it less?
Because I don't have to build it so fast. I don't have to worry about compact density. Versus when I put everything in the die here, I have to design and manufacture at the same time. I can't do it afterwards. Right? So you can have a USB drive. At any time you can purchase and plug it. You don't have to purchase at the time of the computer was manufactured. Right? Because it requires manufacturing process. Also, there's only so much space. Right? Versus when I generate it, I have an external stuff. Versus when I go into the L2 cache, these are probably sometimes hundreds to thousands of dollars per gigabyte. Okay, so the cost place is significant. So when you're a big corporation, when you're trying to do that, right, you have to keep that factor in mind when you do that. Okay, so let's say if I'm in Amazon and I have 30 million customers, okay, Am I going to cost all of this, assuming all 30 million customers going to be online all the time? Probably not, right? I have to put the model that, hey, only certain piece of, like a segment of the customer will be online and certain customers will be offline, and then they will do it. However, I have to worry about things like, hey, it's a million plus customer going to log in. But not necessarily all of them will be doing a purchase at the same time. Somebody might be just looking at the browser versus somebody might be performing a purchase, or somebody might be just looking it into it. So there's going to be different pieces of data that everybody needs. But then I have to worry about the surges, right? So Black Friday or a special Amazon Prime Day sales, right? You see it, the spike goes up, the number of customer goes at the same time, right? Same thing goes like it's, hey, if I'm like it's kind of buying a concert ticket, right? The moment that, depending on the popularity of the singer, the date when the concert is going to be open, like I'm going to see a huge spike because everybody wants to get their tickets before it, right? So if you look into the OSU football tickets, right, and if you plot a graph of, hey, when do people come to get the game? That is 2 play times, right? When they open up the season, right, where the students and all the other alumni can buy the season ticket, you're going to see a spike. Second time, you're going to see a spike is right before the key games, like right before the Michigan game. If they both are ranked, you're going to see people trying to like it's purchase it, get into the last minute, right? So you're going to see a spike going through it. So how do you deal with spike, right? So everything was physically kind of confined to the stores. You didn't see a spike, right? Because even if there are like 1,000 people standing on the line, there's still only 4 cashiers checking them out. But if that situation has changed now that I can do it from internet, there will be 1,000 people standing on the line at the same time, checking it out, right? So I have to deal with that. And the way that they deal with it is known as a multi-tier architecture. Okay. So in the multi-tier architecture, they kept the business layer as a, remember 3 layers you had? Application tier, the data tier, and the presentation tier, right? So the application tier is where all of the business logic stay. So that stayed the same. But the front end now it's kind of broken down, right? So remember what I talked about, right? I may be accessing it from a tablet or from a PC, from a mobile, or from the big Taylor machine or whatever the bank locations are, right? So my user interface is going to be different because the way that you see certain banking information on your phone, it's going to appear different than when you sit in the big computer, right? Where you have 15-inch screen. So, but the information is still the same, right? When I pull the, hey, show me my account or show me the balance or allow me to transfer, right? The information is still the same, right? So my presentation of what information needs to be, it's going to be separate than my presentation or user interface layer. So they break it down and says, here is what you're going to present it, but here is how you're going to present it, right? So what is going to be presentation layer and how is going to be UI layer? So they separated that out because now all I have to do it is build a separate UI layer if there is a different form factor, right? Everything else can still remain the same. On the flip side, on the data layer side, now instead of 200 concurrent connection, I have to worry about 1 million concurrent connections. But I can't keep everything in the memory, right? So I need to figure it out. What is the very fast memory, but there is a cost associated with it, pretty high, versus it's okay to put this information in the slow memory. So they started looking into architecture where when somebody wants to access a data, right, they say if they are currently actively performing an operation. So let's say if I'm like it's going on an Amazon website, logged in and actively browsing the products, they're going to bring all of my profile information and those products into this memory here so that I can get a quick response. So if you notice it, right, the first time you log in, it will take probably a second, but then subsequently you will get a quick response. What happened is at that point, to bring the data from this memory into this memory and cached it. So that every subsequent request you make it's not going all the way to the slow layer, it's coming into the higher, right, which is the RAM layer, pretty much. So now I improved my performance almost 1,000 times. But I have a limitation, right? I can't keep 1 million customers' information in here. So I'll put a logic where, hey, if you're no longer active, I'm going to push your data back into this one, right? So, and whoever is active, I'll move their data. So the architecture had to change it in order to allow the data access layer to be much more faster. Now, from a user point of view or a business analyst point of view, now you need to start thinking about, hey, let's talk about the requirements. How many users are going to be concurrently going to access it, right? At any given point, how many people can do it? What should be performance, right? Oh, by the way, what information needs to be displayed if I'm using a phone versus I'm using the entire screen, right? What information you need to bring it if I'm within the corporate network boundary versus if I'm in a public internet, right? All of those things starts coming into play. As a business analyst and an architecture, you need to start thinking about those questions. And that adds a complexity, right? That's when you're trying to talk to your user and says, hey, how many people are expected to come in at any given point? So that you can tell the architect says, make sure you can handle 1,000 people coming at the same time, right? When you look at it often, right, when there is a big streaming event happening, right? Like if, let's say there's a Super Bowl, right? A lot of times people stream it through it, right? The number of people going to access it's going to spike at that any given time. Or it says, hey, it's a normal season, normal NFL, probably only a few people will be logged in to see the streams. So I have to plan for those kind of upsurge. Same thing, how many times you encounter, hey, I'm on the Black Friday. I'm trying to go to my favorite store's website and the performance sucks. It takes 10 seconds from the time I click it to get any response, right? Because the site is not designed to handle that much customers, right? Either they had a poor design or they had a wrong requirements. They anticipate only 50 customers versus 500 customers showed up at the same time. So now your system is not designed to handle that, and so everything goes slow. Okay, so that's the multi-tier applications. You guys good with this architecture so far?
Yeah.
Okay. Then let's look at it. Another thing that came in the early 2000s, right, is much more interactions over the internet or a network across the companies. Okay, so let's take an example of Amazon itself. Right? So when you go to Amazon, right, let's say when I go to Amazon and says, I want to buy a book, right? What's going to happen? I'm going to go to the site, right? I'm going to log in, or before logging, I can still browse the books. Right? I'm going to select the book that I wanted. I'm going to put in the cart. And at some point, I'm going to say, okay, let's check it out. I like this book. I want to purchase this book. So when I put a purchase, right, it prompts me for the payment information, right? So I'm going to put in my credit card information, right, or a PayPal or whatever the mode payment. But let's keep it simple that, hey, I'm going to put the credit card information. I put the credit card. Well, that credit card is going to be issued by my bank, right? And I could be anywhere in the world, right? So Amazon has to worry about, hey, how do I make sure that this is a valid credit card? It is for the person who is claiming they are, and I can charge the amount that is trying to it's get this book on. Right? So they're gonna run into that issue. But they said, wait a minute. We have this massive global payment network. It's called Visa and MasterCard. Right? They already do that for all the banks. Right? So when you go to any of the ATM machine, right, with the Visa card, it automatically goes it. And those networks essentially connect all the banks together to do that. And if I'm it's a bank, and if if the credit card that I've issued it, I know, right, the customer, what they're allowed, who they are, and how much money they are allowed to purchase against it. Right? What is their credit limit, sort of thing, right? So if I'm an Amazon, right, I'm not going to try to it's go and say, hey, I'm going to build my own payment network. What if I can tap into Visa and says, I'm going to use your payment network. Here is a credit card information. You go get whatever the validation needs, and all I care is you tell me valid credit card, and I can charge that amount. You can perform that transaction. As long as you do that, I'm great. Right. So I go through it. I put my credit card information, I purchase it. Now think for a moment, right? Amazon didn't use all of their networks and all of their systems only to perform my transaction, right? They actually went out to the bank or a Visa and used their services to perform the transactions. But they need to know to transfer. And it gets more interesting, right? Once I purchase it, I'm going to say it's Amazon, ship it to me. And provided that. Right. So in early days, Amazon didn't have their own truck, didn't have their own shipment. So they will connect it to either FedEx or USPS and says, hey, here is the item. I'm going to generate a tracking number, and I'm going to it's going to deliver item to you. You go and make that entire delivery. But as you deliver, as it moves through your network, I want to know where they are so that somebody at the site can come and says, where is my order or where is my shipment? Right. So I not only now need to interact with the payment network, which is not part of my own domain, but also shipping network, which could be another domain. Right. Earlier, it was not possible, right? Because I had to build a dedicated network going from Amazon to Visa or that in order to do it. But with internet, everything was possible, right? I can just go and say, hey, give me the URL where I need to connect to you. And then I'll kind of interact with you in a secure way to do that. Right. So the whole concept of services came in, where it says, hey, the corporations now are providing a solution to the customers that essentially consume services from multiple corporations to perform it. So I need to evolve an architecture which allows me to do that, right? Because it's now no longer everything is confined into my systems. I have to go interact with the other systems to do that. So that's the architecture that they started with, the service-oriented architecture. Okay. They started thinking about, hey, the presentation layer, so when I go to the Amazon's website, right, they're going to just give me a presentation, depending on whatever the interface I am, right? But behind that, they're going to put it, what are the type of things I'm doing? I'm purchasing a book, I'm browsing a book, right? So there are processes that I'm performing it. So they started putting in orchestration layer. It says, hey, if you want to purchase an item from an Amazon, here are the 5 steps that you're going to perform, right? You're going to look at it, items, you're going to select an item, you're going to put it into the cart, you're going to pay for it, and you're going to identify the shipping stuff. So here are the 5 steps. So as they go through it, they say, hey, each of the steps is now going to call a services underneath it. Now, those services could be within my own company, or it could be external, right? Like a bank or a USPS or the FedEx. Right? So they started talking about, hey, orchestration layer is going to determine what steps I'm going to do it. In each layer or each component or step within orchestration is going to identify what services I'm going to call. And behind each services, there are my original traditional systems, right? Because when the banks went in online and allowed you to do, hey, bill pay, right? Which is somebody else's, I'm going to transfer the money from here to there. They didn't rewrite the whole backend system, right? Because there's multiple years of investment and billions of dollars of investment in building those systems. So those systems still stay there. You just build a layer on top of it and expose a service that then others can use it. Now, when you look at this architecture, right, now I can go across the boundaries of the corporation. But it also now challenges a different challenges for me as a business analyst or an architect. I have to now worry about, hey, what is the interface for each one of those external systems are, right? How often it'll get updated, what is the rules, what are the security requirements, how am I going to connect it, what is going to be the performance? All those information I need to capture as a business analyst. Oh, by the way, I also need to capture what information I'm going to pass it to them, right? So when you're doing a payment, well, what kind of information, right? Earlier, hey, I could collect all that information, store into my profile. Now I can't do that. I have to ask them, hey, is that whatever I stored previously, you want to use that? And that will have, I can pull it up my name, right, on which the credit card is issued, the card number, the expiry date, the CVV code, right? Amount that I'm looking for to charge it, and I'll send it. Then I also have to identify, hey, what are the kind of information I'm going to get back, right? I could get it either, hey, this is an invalid card, or I could get it, it's a valid card, but it's an expired. Oh, it's a valid card, but you don't have enough credit to purchase this particular big amount. Or it's a valid card and you can purchase, and oh, by the way, here is the reference number that I kind of created for your transaction. So it goes through it, and then you can utilize this number for any future interaction about this transaction, right? So as a business analyst, I have to list out all those scenarios and says how it's going to happen, what interaction is going to happen, so that somebody can program that. Okay. Good with me so far? Complexity, you see how it went it from a monolithic going into this? Okay. And then 2007 came, and Mr. Steve Jobs changed the whole landscape. Right? There were mobile phones before that. Don't get me wrong, but there were touchscreen mobile phones before that. That people were using it, but he made it very easy and intuitive and a much more common. But now, as a software developers, that poses a problem to me, right? Because I had a system that was kind of designed it in the notion that you will always stay connected, right? So if I'm connected from a laptop, my connection is always there to the internet. But if I'm on a mobile and I'm driving at 70 miles an hour in Idaho and Montana, there are going to be pockets of the roads where I'm going to constantly lose the connection because they don't have a cell towers. Okay. So if I could be performing the banking transactions, halfway through it, I lose the network, right? When I gain back the network, well, what happens? Did my transaction go through it? Do I initiate it? Do I don't do that? Same thing, like let's even keep a simple example of email, right? You get an email on the phone. As soon as you connect it, it tries to download email, right? But it doesn't try to download everything. It just tries to download, hey, from the moment that I was last connected to this moment, what all email I got it, can you download it on my phone so I can look through it, right? And whatever I kind of typed it in that you couldn't send it, now synchronize and send it now, right? So that adds a complexity that I need to think about synchronizing the server with my mobile application. And my phone is going to have probably some sort of storage and some sort of database within that. So when they make a request, they said, hey, this was the last time I connected. Give me everything from this point onwards. Okay. Now that requires you to put an additional thought into the requirements. Well, how do I deal with this, right? So if I'm doing a stock trade and I lose the connection, I probably don't want that trade to execute as soon as I reconnect back because the prices could have changed significantly up or down, right? And I may not want to do that. Versus, hey, I'm checking an email. I do want to get it, whatever the last one is. Right? But I want you to synchronize. If I deleted certain things, I want you to synchronize and delete that from the server too. right? So now, as a business analyst, you need to think about what will be the behavior if they're connected into an environment where they're constantly connected and getting disconnected. Versus they are connected and I know that they will finish the transaction in that connection. Okay. So those are the complexity gets added. Another complexity gets added is everybody's going to have a different browsers, right? So when you look into it, iPhone has a different browser than the Samsung, versus when you look into Nokia, they have their own operating symbiosis system. So now I have to deal with that. Hey, not only just my presentation layer is going to be different, but my interface and the operating system on which it's running are different. Well, can I display it this way or can I display it that way? So a lot of times, when you look at it, right, the information will get displayed differently on iPhone versus Android phone. So I have to worry about all those nuances also. As a business analyst, I need to capture, put all those behaviors so that they can code it accordingly. Okay, good so far? Okay, it's kind of like it's hour and 40 minutes, so let's take about 10-minute break. Right, and we'll start back at 10:53. So Oliver, for you, like there is a water here and there's a bathroom there. If you want to like do that, you want to stretch it. And we are recording this session, so Harshal will get you that.
So we can still listen.
You can still listen from home, right? He will probably, since we are recording this on cloud, it sometimes takes like 4 to 5 hours for the Zoom to process that and make it as available before we can upload or send you a link. Okay. So sometimes it takes a day to get through all the processing in that. Okay, but we typically start at 9. We'll go through that, right? Because you definitely want to try to be here by 8:45, so you don't miss anything. Okay, so let's take a quick break. Pause the recording in case if I don't forget, remind me to restart the recording. Let's do that. So we have 2 more people new in the room. So let's go through introduction. So what we went through it, Oliver, is a round of introduction, which tells who you are, a little bit about your background and what you expect out of the course. So why don't you go ahead?
Okay, my name is Oliver.
You're speaking loud so that she can hear you.
Oh, my name is Oliver Sapon, and I'm originally from Ghana, West Africa. And I love to do the IT for the rest of my life, so I started doing alongside in Maryland. But one of my friends introduced yours to me, and then I tried to testify this as well. So I'm just hoping God to come out with a good thing in the future.
So what's your education background? What was your previous experience with the computers?
I was a diploma.
But what was your previous experience with any of the systems? You said you've been doing computer stuff since you're in Maryland. So what kind of things you've been doing?
Actually, I was doing DevOps and then the Linux as well. Yeah, I started it for it was nine months. So right now I'm trying to start this software as well so that I can learn more about it before I start working with it.
And Oliver, what do you do now?
Actually, I'm a caregiver right now.
Okay, 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 gotcha. All right.
Okay. What
Cynthia.
about you, Cynthia?
Okay, my name is Cynthia. I'm also from Ghana, West Africa. And right now I am a nurse.
Okay,
And I want to do the IT so that I love working from home. So that I can work from home.
that's your Canada.
Then the weekends, I'll do my nursing, like maybe Friday overnight, Saturday, Sunday.
I see.
Then Monday, I do the IT.
Wow, so you're planning for 7 days a week.
Oh, yes, yeah.
Just be mindful, it's a double. It's working from home.
So long as I'll get my job working from home
Right,
and then money, okay.
okay,
Yeah, that's why I'm here.
great, great.
Yeah. No, working from home is great. Like, don't get me wrong, but it also sometimes deprives you of the opportunity to learn from each other, from your team members.
Okay.
right?
It is
So
boring. I'm working from 1 year from home. I forgot driving.
She doesn't like to
So
drive.
I drive 30 minutes today because I avoid highway. So it's kind of depressive at home.
yeah, I see it a different way though, like it's working from home and like specifically when you're working in a global environment, like so I have a team in India, in Singapore, and UK, Argentina, and US, like at these 3 time zones. The problem is you're never turned off,
Yeah.
right? It's so easy, like it's get up at 6 o'clock in the morning, just do that. And then like Singapore is 12-hour difference, so like it's, hey, they are up at like it's 8 o'clock their time. Let me just quickly hop on, interact with the team member because it's so easy, right? You don't have to like it's go change to do that. So that's another aspect you have to think about is your long working hours. Because yes, you are avoiding commute, but how many of you like it's kind of, hey, I reach in the office at 7:30, so I'm gonna just log in only at 7:30. You log in way early on that, right? So it's again, working from home, it's a double-edged sword. So as Gita pointed out, right? It's you forget driving, right? But like it's if you're sitting it like it's I have a few team members in New York, right? And they absolutely love working from home because they don't have to deal with 2 hours commute every day morning. Right? That 2 hours, even if they like it's log in 1 hour, they have an extra hour with the family. So, but again, having that flexibility is great, right? Now, in the healthcare field, I also started seeing it like the teledocs. So it's getting there. It's not there, but it's getting there.
Yeah, like during the week, I will get my ass up away from the house
Right.
and go to work like
Okay.
during the night. So it will not be like I will be home all the time,
Right.
but yeah.
That's great. That's great. So
All right.
welcome to all of you. Okay.
Thank you.
And I'll let Dilip continue
All right.
the session.
So let's get started, right? So far we talked about the different architecture, right? Another aspect that you need to get now, Noel, as you start looking into whether it's a quality assurance person or a business analyst person, or even a software developer, it's essentially how the software gets built, right? So a lot of times it talks about what is the software development lifecycle. Or a lot of times they use the key like short form word of SDLC. Okay, so like it's there. All this a lot of times talk about SDLC. So the folks in IT worlds are very good at like it's acronym things the heck out, right? 3-letter, 4-letter acronyms. You can see it flying all over the place. And so this is one of them, SDLC. So just like it's when I talked about like, it's, hey, what if you're building a house, right? It goes through a process. Same thing goes through the process for development lifecycle. Okay. So let's talk through the process. Like it's if I'm building a house, what kind of process I go through it. So if you think about it, what is the first thing you do it when you plan to build a house, right? First, you make a decision. Do I really need to build a house or do I need to rent a house, right? So there's always going to be a decision making. And that decision making is going to involve, am I ready financially to do that, right? So that's always going to be the first. It's not going to be, hey, whether I need a house or not, right? That's definitely one thing. But then even if I need a house, do I have the money? Am I ready to go build a house? Right? So that's the essentially a lot of times talks about the planning phase, right? Let me get it. Once you have a money and you said, yeah, it makes sense for me to buy a house rather than do a rental, right? You're going to look into, okay, what kind of house you want, right? Do you want a multi-story? Do you want a standalone home? Do you want in some sort of flat system? Do you want a ranch style where it's only one level? What kind of house you want, right? So you start putting together what do I need it? What capabilities, what features I need in the house? How many bedrooms I need it? right? So you start doing analysis. I need a house, but what kind of house I need? What are things I needed in my house? Okay. Once you design all of that, hey, I probably need a single story house, but like it's 4 bedrooms, this and that. And I decided, oh no, you know what? But as the kids get in, I want to have a separate room so there is no noise in that on a different floor. So let's just do a multi-story house, right? So you put all those requirements. The next thing you do it is, okay, now that I know what I wanted, right? I probably need to go to an architect and says, hey, can you design this house for me? Here are the things that I'm looking at. Right? Now, either you can go directly to the architect or you can hire a construction firm, which will have an architect, which will pull together an architecture for you. Sure, is this what you want? Yes, and then they will go to the county and get that architectural approval, right? So they will design your house. Okay, once your house is designed or the approval got from county, the next step is, okay, I know what I wanted, I have designed, can we go ahead and build it? Right, so that's where the construction starts. So you have an implementation phase. I'm going to take that design, I'm going to implement to actually become a house. Right, so to build a house, and at the end of the building, then what are you going to do it? You're going to say, okay, go ahead and test it. Right, so you're going to go look into it, says, hey, let me turn on the water in the kitchen, make sure plumbing system works. Let me turn on the showers in the bathroom, make sure those things work. Right, let me turn on the electricity. Let me flip in the switches, make sure electricity works as expected. Right, I'm also going to do visual inspection. Hey, I asked you multi-story with 3 bedrooms on the first floor and 2 on the second floor. Did you build it that way? Is it built according to the design that I kind of asked you to do that? Right. So you're going to do all those things to testing, right? You're going to do either walkthrough, you're going to have an inspector coming from county, which are going to do all those things for you. But at some point, you're going to test it. At some point, it's okay, now it's ready. At that point, right, you're going to say, it's okay, now it's ready, so I can move and I can live into it. Okay, once I start living into it, right, and I says, hey, I want to like it's build a deck, or I want to build another, like it's a long sunroom, right? That's an addition. That's kind of a comes into maintenance part, right? Now I'm building it on top of things, right? Or, hey, my drainage system is not working properly. I need to have somebody come and fix it and make sure it works expected, right? So that's your normal house development cycle, right? So if you think about it, right? You started with the planning, right? I need a house. Analysis, what type of house I needed, the design, what actually like its house will look like it, then implement, construct the house, test it, everything works, I'm going to accept it, I'm going to move into the house, then I get into the maintenance phase, right? That's your normal development life cycle of a house. Software is exactly the same. Okay, if I'm a business, I'm going to like it, make a decision. Does it make sense to build a software to support this particular thing? Or if it's cheaper for me to do it manually, why would I build a software? Right? I would just keep doing it manually. But at some point, right, you're going to make a decision. Hey, I cannot keep hiring more and more employees. I need to automate it. So I need to build a system, right? So you go through the planning to make a decision. Does it make sense for me to build a software or this capabilities? Then you go into it. Yeah, it makes sense. Well, let's talk about it. What the feature, what other capabilities needs to be of that software? Let's identify all the requirements. Then I need to look into design. How can I build a system that fulfills all those requirements? So this is where all the architecture that we just went through it, like it's from a monolithic all the way to mobile architecture. We need to look through it and just, what kind of system is going to help me solve this problem and meet this requirement? Once I do that, then I'm going to go ahead and actually implement that software. I'm going to write the code to do those things. Okay. And as I write the code, that needs to be tested. I'm going to test it, make sure the code does what it's expected. And at some point, I'm going to be done with the testing and done with the coding. And I'm going to say, okay, here is your software. Right? They're going to go ahead and test it from a user's point of view, just like what you do it in the house, right? I turn on the switch, make sure electricity is working, right? I turn on the AC to make sure the event system is, everything is working. And then they accept the software. They pay you for the software that they build it, and then get into the maintenance. So that's the software development lifecycle. It's exactly the same as what you would anticipate in the normal world.
Maintenance means in use.
It's in use, right? But then, hey, there was a new operating system patch came in. Now it all of a sudden it started breaking. It doesn't work anymore. I need to go fix it, right? That's the maintenance work. I'll fix it, make sure it's working back as expected. Right? Or like it's a wear and tear. So any questions on the development lifecycle?
So we are using this nowadays.
Again, irrespective of what methodology you use it, this is how the software is developed. These are the various phases in the life cycle of a software. Okay. Now, think of the house that we talked about, right? If I have the specification and I go to 3 different builders and ask them, build the house, will they build exactly the same way or same process?
Yeah.
They won't, right? They all will do it differently, depending on what is more suitable, right? And also it depends on where you're located, right? If you're building it into, let's say, Canada, right? Where 8 months things are covered with the snow, right? The way you build it and the order in which you build it is going to be different than the way you build it in Florida, right? So there's going to be some way it's going to be. Same way in the software development world, depending on how people decide to build it, they're going to use a different methodologies, right? There are 3 methodologies which are fairly common. Okay, one is waterfall, the other one is Agile, and the third one is a rational unified process, or a lot of times known as a iterative methodology.
The third one was this. The third one.
RUP, or rational unified process. Okay, so let's talk through each one of them. Okay, and I'll start with Agile world. Okay. In this, essentially, it's getting a more and more where people are trying to do it. Okay. So before we talk methodology, I want you to think about from how the world has evolved, specifically in the last 20 to 30 years. Okay. When you reflect back into 1990s, right? The way the world worked it is the companies will come out with a product, right? So if I'm a bank, I'll come out, hey, here is the savings product that will use it. Here is the credit card products that you can use it. And then I give it to the customers, right? And customer will start using it. Whether they like it or not, they will use it. Flip it to 2015, 2017, or even today's world, right? I, as a customer, essentially said, I want this way to be things to be done, right? And if you're a bank who doesn't give me an ability to do an online banking or bill payment, I'm going to go away from you to whoever is providing it, right? And I'm going to define what I want, not what you're building as a product, right? So the whole world has shifted it from, hey, we'll build the product and people will use it, to shift it. We need to build a product of what people want and how people want it and what they want, right? So if you think about it, right, and I don't know how many of you interact with the kids in the college. Well, I have 2 teenagers both out in the college. And the most common thing that I've seen it is they never go to the banks. They do everything on the phone.
Wow.
Okay, that's the reality. Including, hey, in the old days, like it's people like me will have physical cash, right? Or the checks. Hey, if I need to give somebody some money, friend to things, right? If I tell my friend that, hey, you're in the store, can you pick this for me? And then I'll write a check or I'll give him a cash in the olden days, right? That's how the banks used it, and that's how they bank. Well, some of the banks still stayed that way. But when the teenagers came in and said, I don't want to go to the bank, I don't want to like it's carry a checkbook or write it, right? So things like Venmo came in, where they said, hey, you know what, I can just kind of text you with your number, here is how much money, and get it. I don't have to write a check, I don't have to do anything. Right, specifically with the college going kids, like they all like to go hang out for dinner, hang out like the grocery bills and everything. Much more easier for them to utilize that. Right. So the behavior is also changing of how the customers are doing it. So you have to quickly and constantly adapt to what the customer wants. Right. You may have a plan. Hey, I'm gonna like it's gonna build this in my product, and this in my product, and this in my product. But you have to see how your customers are reacting, and based on that, you need to make a decision to change things that you're doing a lot more often than what you used to do it in the 90s. Right. So you need to build products quickly. At the same time, you don't need to build the entire product quickly. Right? You can build the feature that the customer wants it right away type of thing. And then as they add more features as they need it, you can slowly expand it, the product to meet the need. Right? So that's the mindset that's behind the Agile world. That you have a vision. This is what I wanted as an end product. But I'm not going to build everything to first go around. I'm going to build a small component. I'm going to try it in the market, start getting my money, and then I'm going to build a second component. Okay. I'll give you an example that probably like it sets everything in your mind. Right. I said one of this time of the year, Uncle Sam wants it is tech software, right? Have you looked at the tech software, how complicated it is? So if you look into the laws that the Congress creates it, right? Typically, it's like this thick paper with all those things. And I'm not joking. It's literally this thick. Every year they change. Okay, the deduction and everything. So let's say if I'm a new company wants to do it, I want to build a tech software, right? There are approaches I need to think about, right? Because it's this thick, it's probably going to take me 4 or 5 years to get all of the variances in that, right? But when you look at it underneath the hood, right? That's for everybody in the US. But when I look into it, okay, let's just segment it out. There's going to be a people who are filing as only as a single taxpayer, right? There will be joint, there will be standard, there will be deduction, right? But let's say 10% of the people files 1040 easy, right? Simple calculation. I don't need to put any complicated things into it, right? I can start to say, hey, I want to build a tech software. But you know what? The first thing, I'm not going to worry about everything. I'm going to first focus only on the people who are going to do 1040 easy. It's a small piece. Let me build it. Once I build it, I can start selling to the people who are doing 1040 easy. Right? They don't need, like, I understand there are other people who are like, it's kind of doing it joint, doing it itemized, doing with a whole bunch of schedule. I don't need to worry about any of those initially. I can build this, I can start getting the money, right? Because now I can sell it. Versus if I take an approach, you know what, I'm going to build everything. And look at that, it's going to take 3 years. Guess what? Congress changes the law every year. So as soon as I build it, the first thing I need to do is, hey, what are the laws that they change? Let me go back and refix it things, right? And for that 3 years, I can't get any money. I keep putting the money in, and I don't even know whether it's going to be worth it for me to build this software, right? So in that scenario, right, I may have a vision, I want to build the tech software. And I said, you know what? The first thing I'm going to do is do only 1040 easy for a single file. I don't want to do anything else complicated. It's a small segment. I can do the entire SDLC around it, right? I can just say, in order to do that, what are the requirements for the 1040 easy? Well, let's make sure it's a design. Let's make sure you code it, test it, and deploy it so that I can start selling it. Okay. Once I start selling it, I can think about, okay, now that's done. Let's go into a little bit more. Let's just do it 1040, but standard deduction, single filers. Then I can add it, the married filing jointly. Then I can do a household. Then I can do it, right? So I can gradually build it. At any point, if the laws changes it, all I have to do is change only that small portion of what I have already built it and then manage it. Okay, so that's how I eventually do that. The key difference here is at every iteration, I add a value. I deliver something into production that I can sell it to the customer. Okay. Typically in the software development world, this iteration is typically between 2 to 4 weeks. Okay, take that small. Now, as the lot of the product and maturity companies have done it, right? They do a lot more often, right? Does anybody know how often Facebook releases the new feature in software?
Every week.
They have every hour releases across the globe. Okay,
Every hour?
every hour. Amazon Web Services, which is their arm to do all the software and the data center one, they release it every hour.
Wow.
Your problem. Okay. So you can make that iteration very small, right? And the way they do it is because they have multiple team working on multiple features, but they constantly integrate and releases. But that's where the world is going. You want as a feature as a customer. If you waited for a year, somebody else has already captured the market. Right? Yahoo, AOL, does those names sound familiar? They did not adapt to the changing world. They're all our history. None of them exist as a standalone company. And at one point, they were the most valuable company on the stock market.
Yeah,
Kodak,
things change.
right? So that's what the agile development is done. When you go out in the real world, you're going to start seeing that the people are like shifting it towards that. Does that mean everybody's doing? No. Does that mean everybody's doing right? No. Right? But this is where the industry is growing. This is where the small and niche companies are like, it's getting an advantage because they don't have to have a massive infrastructure. They can just do it this way. Okay. So that's one methodology. The second methodology is a rough or rational unified process development. Now, this is typically used for a large projects. Okay. As I told you, like I'm kind of like it's more science book. So think about NASA wanting to send people to Mars, right? Doesn't happen overnight. But you can't say, hey, I'm going to build everything into one. Then I'm going to ship people to Mars. What if things doesn't work halfway? Can't have people die, right? So that means I need to figure it out small incremental way. I need to prototype, I need to test it, and I need to assemble and make sure everything comes together, right? So that's the concept behind the RUP or rational unified process. It's an iterative, okay? It's not very commonly used, but it is kind of used in a big, large projects and by large corporation. It originally was designed by IBM, right? And they built it like it's aircraft carrier systems. Or when they build it, like it's kind of a Lockheed did the F-16 and F-22 fighter plane development, those kind of scale that they look at. Okay. So this one has 4 phases. Okay, the first one is inception. then it's elaboration, then construction, and then there is a transition or a deployment phase. So if you look into the vertical axis, more or less you can map this thing to your SDLC lifecycle phases, right? So you have a requirement, right, which is part of analysis, then you have a design, then you have implementation, then you have test, then you do deployment. And since this is a large thing, so you have to do the configuration management to make sure, okay, every piece that I kind of change it still works seamlessly with the other pieces. So what they try to do it is first, let's just do the business modeling. So when they are building the system to go to the Mars, right, the first thing they do is let's just do a simulation based on the calculations and everything that we know in terms of payload, in terms of physics, in terms of the geographical and astronomical measures. I need to do a modeling that says, can I do it? Right? And then he says, okay, yeah, you can do that. Well, what are you going to do? It is in the initial phases, everything is going to be models, right? So everything is going to be, hey, I'm going to build an engine. I'm going to test that engine. Can it work for this long? Can it fire this much? Can it generate this much thrust? Right? I'm not sending people to the Mars yet, but I'm like checking out the engine and saying, making sure does it work. Right? I'm going to analyze the requirement. Well, what kind of engine I need it? Right? Can it operate in what kind of condition? Right? Because hey, if I'm working it here on the Earth atmosphere, it's not going to be extreme cold. But when I'm up in the space, it's going to be extreme cold and extreme heat, right? The variation. Can it still operate in that? And guess what? My engine is probably going to be turned off because the flight goes into the cruise mode when they do it interplanetary, right? And then I had to fire up those engines when it comes back to break it so that gravitational force can catch it. So those kind of things that I need to do it in the requirements and model. Then I can analyze it and start building it a small pieces of that, individual pieces. Okay. And as I build it, so that's why you look at it, right? So if you look into it, right, in inception phase, you're going to focus more on the modeling and more on the requirement. I want to understand what exactly I'm going to build it. Then in elaboration phase, I'm going to say, okay, can I build these things? Can I model it? Can I do all the prototypes? Can I build all the components? Right. So if I'm building a systems, right, aircraft carrier systems, can I do it? The takeoff, can I do the landing? Can I do it like it's kind of surveillance systems? Can I do an imaginary system? All of those things comes together. And then it says, okay, now I'm going to put everything together. Right. So if you look at it like it's 2 weeks ago, NASA tested the Artemis rocket. Right. They kind of rolled it out, assembled the whole rocket, filled the fuel, empty it, did the wet, what they call it as a wet testing to make sure, can this rocket work to even go to the moon? Right. So that's kind of construction phases. Can I build the software, all the components together? Will this work? Right? Each component, I model it, everything is working fine. Now I'm actually building and bringing it together. Does it work as expected? Once it works as expected, can I deploy it into production environment so that now everybody can use it, right? So that's when you see it, right? The deployment is a lot more in the transition phase. There's almost no deployment in this phase. Okay. So what that means is I'm going to do an iterative. Now the difference between Agile and this one is even though I'm doing iterative, hey, I'm checking it, but I'm not checking the entire solution. And I'm not giving the value, right? So while I'm building the engines, did I send anybody to Mars yet? No. Right? Did I do all this wet testing? Did I send anybody to Mars yet? No, there's no value, right? Versus in Agile world, hey, I will build it, I'll send the people, like so if you look at the SpaceX, right? The way that they build it is, hey, I'm going to build a cargo ship first. That's going to test it, how I can get it from Earth to the low orbit. Then I put the people on it. Now they're working it to say, can I put it the people for that long? Right? At every incremental, I'm adding a value, right? Because I'm supporting the space station. I'm getting the money from NASA. I'm sending the people. In fact, they just did the first private mission, which just started on yesterday, Friday. They get the money to continue to build it, right? That's the Agile mindset versus the way the NASA does it is a rough. So does that make sense? You guys good with that? The difference between those two? Okay. The next one, it's kind of traditionally has been kind of most common method people had used it. It's called a waterfall. Okay. So till probably I would say it's early 2000, this was most commonly used. This is still most commonly used method in many organizations to build the software. Okay. In this one, the mindset is I need to know everything before I can start anything. Okay. I want to know everything that what you wanted before I can start building a design for it. And if you change anything at any point, I need to go back and redesign things. I'll go like it's, once I'm done with the design, I'll start implementing it. If you change anything at that point, I'm going to go back to the requirement. Tell me now what do you want, what changes you want. Let me redesign it and then come back to the code. Right? So just like a water, right? Anytime you make a flow change and you want that water to reflect something change at the top, you have to put the water at the top, and then from top, and it's going to flow back same way. It's not, it cannot skip it. It has to go through that. That's the mindset around waterfall. I'll start with the requirement analysis, go to the design, but I will not start till I have every requirement understood. And from a design to code, code to integrate, to test, and to prod. Okay. This is the scenario. Remember, I was talking about the text. Hey, I'm going to understand all the requirements. I want to make sure everything is done. I'm going to build the whole 9 yards. Oh, by the way, every year when the progress changes, I'm going to go back, redo it, analysis and that. Most likely, I'm going to get into the cycle where it's going to take me 4 or 5 years to build a software. What happens during that 4 to 5 years, I have to keep paying my development team the money to keep building it, right? I'm not getting any money from any of customers, so there is no revenue coming in. That means I have to borrow money to sustain this development. And guess what? After 4 years, I may just say, hey, you know what? My software is too expensive. I can't compete in the market with the competitors. So I shut down the project. You'll lose all the money. Right? That's a fairly common scenario than what you think. Okay. So, but that's the waterfall development system.
That method for me is you can lose time, you can lose money with this one for the company. It's not working at all. And especially you don't have also the customer is not really involved in this case.
It's not like it's sit down with customer to get all the requirements.
No, only in the beginning. Can you imagine if you already understand integration or coding something?
Completely understand.
And the customer come and say, okay, I don't want this to be like that. I want you to change this. So you're gonna go back. Can you imagine all the time that you spend or all the money that you already placed in it? It's not good for the company.
It's not good. Agree. But depending on what the product is, sometimes you want to know everything.
Mhm.
The hardest part is not that, hey, I need to know all the what customer wants. Even in the Agile world, the hardest part is to make sure when you go from first iteration to second iteration,
Mhm.
if you end up rewriting everything,
Mhm.
you cannot sustain it. You cannot deliver in that time frame,
Mhm.
right? Think of it like it's if I'm building a house and I build it in an Agile manner,
Mhm.
right? That means, hey, I'm going to build the first floor. Then I'm going to build the second floor. Oh, you know what? It would be nice if I were to build this also on the first floor first. So I'm going to go back, add another room, add another room. Do you think it's going to be a nice house? It's going to be an integrated house.
At the end, maybe.
No, like, because remember, like it could be in the end, but think about the cost it's gonna incur. Because I already put the plumbing systems on the ground, already my framing thing is done, already my foundation and everything is laid out.
Yeah.
If I add another one foundation, it's not gonna be joined.
Mhm.
Even if I put the frame, it's gonna be separate frame. It's not gonna be joined unless I break that old frame and connect it to it. In the software development world, similarly, the architecture, if you do not architect properly and you want to add an additional feature, that triggers the entire rework of the system. Okay, so I understand, like, you can say, hey, by looking at it, you always say, yeah, the waterfall is the worst scenario, and this is the best. I want to use this.
Yeah.
Using this requires a lot more discipline. You don't have PSM certification.
Mhm.
I'll tell you, it takes the teams sometimes 5-7 years to become a mature team, even to do the delivery of the software.
And,
So it takes a time. But the mindset is you need to think through it.
mhm.
So again, bottom line is there are 3 ways you can build a software, right? I would not say it's one is worse, other one is best. Depending on the situation, you need to pick that.
Yeah, okay.
Same way as depending on the situation, you pick the architecture, what architecture I want.
So if we take an example of building a house, okay, on the waterfall, you're gonna build everything. Though you're gonna know at the beginning the requirement, what the customer want, and you're gonna start building the house. And after that, show everything to the customer, and the customer will tell you, okay, I like this, but maybe I changed my mind. Okay, can you imagine if the customer changes his mind? Right, I'm building the house. Okay, in Agile, I'm gonna start maybe with the bathroom. Okay, at the beginning, the customer say, okay, I want the wall to be maybe green. After that, they say, okay, no, I changed my mind. I want this to be yellow. What did you do?
You incur the cost, you got to repaint it.
And then
Right.
Yeah.
The builder is not going to say, oh, you change your mind, that's okay, let me repaint it for you.
Customer has to pay.
They're going to say, it's okay, it's going to cost you this much, you want to do it,
Mhm,
right?
mhm.
Certain things are going to be easy. Certain things are going to be hard. Right?
Mhm.
Let's say an example, right? It says, hey, I build a house. Right? Now I want to furnish the basement.
Mhm.
Hey, you know what? I want a bathroom in the basement. I want this, a bar. I want an electrical, I want another fridge and that. If you didn't plan it before and you didn't run the hookup and the rough ends for the bathroom and everything, you pay the price, right? You're going to break the foundation to connect it to the sewage systems from the basement. You're going to break the foundation. You're going to run the electricity to connect to your fridge and everything, right? So depending on, did you plan for it? It might be easy. Hey, while building the house, I already had the rough and I already had the plug and connector came in and I didn't activate any of that. Now I'm furnishing the basement, I activate that.
But because in Agile, the house is not already made, you can adapt easily.
You can
Compared
adapt
to-
it, but again, adapt also depends. Do you build an architecture that allows you to adapt it?
Mhm.
Right? If you build a monolithic one,
Mhm.
architecture and says, I'm going to adapt it. Every time you're going to scrap the whole monolith, I'm going to rebuild it.
Yeah.
Versus if you build a service-oriented architecture, you can say, it's great. You want this feature? Let me add another service. Right? So it depends on the architecture you build it. It's going to be a crucial. But sometimes, right, depending on the need, you may have to do it. You may not be do it in an agile manner. You have to do a waterfall. You have to do it sometimes, right? So the bottom line is as a business analyst, right, the techniques you use it's still more or less kind of same in every time. It's just a matter of extent. Do you do it for the entire scope or do you do it only for this iteration? That's all it matters,
Okay.
right? So you will still be able to do all those techniques, but it's just essentially how long you need to do it, how often you need to do it is the only thing that changes. Okay.
So,
Any questions? All right. So let's talk about the value, right? Now that you understand the architecture, you understand the development methodology, and then you want to play a role of a BA, what value you add into the life cycle or into the software development. So there are a few things that you need to do, okay? The first thing, a lot of times as a BA, you do it is assist with the planning or building out the business case. Okay, and we'll see in a moment a typical business case development process. Okay, but the whole point around that is you assist in terms of analyzing, hey, what is the requirement? What are my high level needs, which is driving? What are my business issues that it's driving? Occasionally, you help with the planning and monitoring too. Right? Is it going on time? Is it going track? Is there any changes coming from a customer? Do I need to interact and help plan those changes? Okay. The another role that you play is, hey, I'm going to sit down with all the customers and talk with them. What exactly they want? Right. So what is their requirements? What are their needs? Right. Then I need to make sure I consolidate all the requirements. So if I'm talking to 5 different customers, right, I need to make sure the things that they talk about are not contradicting each other. So I need to bring it together, right? So for example, let's say the builder comes and talks to me, and then he talks to my wife, and I said, hey, I need a multi-story house. And my wife comes and says, I don't want to use any stairs. We're going to have kids coming in. I don't want them to climb over the stairs. Everything needs to be a single floor. Right? So now a constructor or a builder, you're going to ask it, what do you want?
yeah, that's-
You want this or this? Right? So that's the role as a business analyst in terms of if I talk to 5 different users and they tell me different things, I need to bring them together. And says, what do you want? Here are the things which contradicts each other. So let's talk about it. Or in certain cases, you will have a people who are at the higher, right? And they say, this is what I wanted. I know what they want, but I'm paying for it. Right? So if I go to the builder and says, I understand you listening to my wife, but I'm the one who's writing the check. I want you to do that. What is the builder going to do? Who is going to listen? The person writing the check, right? Because if she says that do this way and they did it and I don't write, said I didn't tell you, I'm not paying for it, right? So that's another aspect that comes in the business. When you do a requirement analysis in an organization, you pull all those requirements, you help removing any of the apparent conflicts in the requirement, right? And then you may have to use multiple techniques depending on where is the stakeholder paying for it versus, hey, I'm just a beneficiary. I want this, but I'm not paying for it. And they're going to focus on who is paying for it because even in software development world, right? Whatever feature you build it's going to cost somebody's time. You got to pay that person money. So you need to think through it. Okay. The other aspects that they play a key role is translating and simplifying the requirements. Okay. So when a business talks, right, they think it and talk in the business terms. When a developer wants it, right, they want it, you tell me the specification, right? I understand that this is the business requirement, right? So the business may just say, hey, you know what? You build the systems and I can have up to 1,000 users logging in concurrently using it, right? That's, I'm projecting the growth of 1,000 users, so you better handle it. The guy in the system side, right? They said, okay, you want to use 1,000 users, but how are they going to come? Are they all going to come through the branch? They're going to come all through the internet? How are they going to come? Because I need to plan for it How each one of the segment people are going to come in, and can I accommodate my design and architecture to deal with them, right? So often you end up translating the requirements, what the business wants to what the IT guys want, right? So you play some of those roles. Sometimes you have to break a requirement into multiple pieces to make it simplified and easier to be understood. Right. Well, obviously, you're going to do the whole management throughout the life cycle. When things changes, and you flag it. Hey, this was original. Here are the things which has changed. Okay. And one of the other role that you often play as business analyst is with the user acceptance testing. So when the final product comes out, you help the business. It says, okay, let's just go test it, make sure. Here's what you stated. Here are the tests. Here's the results. See, it matches. Type of thing. So there are multiple things that BA does it throughout the software development lifecycle, and that's the key. Now, this is the graphics that talks about the data that this study was done in 90s and early 2000 about the various projects, software development projects, which is launched, and the success rate, and when they fail it, what was the contributing factors to that. So if you look into it, right, you can just get it back this report, and since then they have expanded it to cover more additional software. So this was original 1994 was the original date, but they did another refresh it in the mid 2000s. But when you look at it, right, here is the pie chart that they talk about capturing the information of why projects fail. And if you look into it, the requirements, which is the primary plan where the business analyst plays a role, is either incomplete requirement or changing the requirement. Because 1 out of every 4 projects failed. So when you have 13 plus 9, it's about 22. Right? So 1 out of 4 project fails. Another past of expectation is unrealistic expectation. Well, you didn't kind of simplify, you didn't specify, you didn't translate properly. All those things causes that. Look at that, lack of user involvement, 12%. I built you something, but I cooked up all the requirements. So when it came to you, it says, I'm not going to use that. I didn't ask for it. I want to use it. Right? So when you look at this wheel, it gives you the sense, the importance of having that business analyst play the role. Okay. Think about it. How many of these failures contribute because of the poor business analysis requirements? Okay. Here are some other interesting numbers. Okay. Even for the system that is built, when you look into it, right, the defects or the bugs that are kind of created in that, more than half of that points back to the requirement issues. Hey, you told it that I was able to handle 500 users. Well, the requirement was called for 1,000. Oh, I forgot to have 1,000 users because I didn't call it this sets of user and this sets of user could give you a single for the use. Right? The cost to fix it, all the bugs, essentially a lot of times exceeds about 3/4 of the total cost. Okay. Another interesting stat is more than half of the projects cost almost double than the original estimate. And here's interesting stats. The average project exceeds its plan time by 120%. Okay. Look at that. The number of projects gets completed on time and budget is 1 out of every 6.
How can we avoid this?
That's where like it's having a very good discipline of getting requirements, understanding the requirements and evolving it. It's the key. obviously project execution and management is also a key. Okay. Out of that, 30% of projects get canned before even it gets deployed. Right? 1 out of 3 or 3 out of 10 never makes it to the day of life. Doesn't matter whether it's a Agile, it's a RAP, or waterfall. So having that said gets you an understanding of why it is critical. Not only just what role you played, but why it is critical. Now, when I look at it, the overall software development project, right? You can categorize them into one of the 5 categories. So any software development that happens, right? When you look into it, it falls at a broader level in one of those categories. The first category is a new system development, right? So I don't have anything. I need to build it from scratch. It's a completely new system, right? If you're doing that kind of development, that's a new system development. Second set is enhancements, right? So if you think about all of these things, right? It's kind of a new system development. It's building a new house from scratch. Okay, enhancements. I already have a house. I just want a deck and a pool. Right? I'm enhancing. I'm adding value to existing one.
Improvement. Improvement.
Improvements, yeah. But I would not say as much as improvement. I would say additions.
Maybe
Additional features, enhancements. Right? Improvement could also be, hey, something is not efficient, I want to improve it. Right? This is not about that. This is the new one. Another aspect is a rewrite. Okay. So a lot of times you will see it, hey, you know what? It's an old house. I want to just gut it to the ground and rebuild it. Right? Same thing, rewrite. I have that system existing. It is really old technology, really sucky performance, doesn't meet the need. Let me rewrite the entire thing. I have that functionality. Can a business work without me rewriting? Yes, it can, but it's not efficient. And there is a need to rewrite it so that we can look at it in the future state. Okay. Then there is a platform migration. This is a crucial, like it's as the software evolves, as the hardware evolves, as the technology evolves. Sometimes you have to rewrite the system to move it to the new platform. Okay. So one of the key things that is happening in the current phenomena is there used to be on-premises data centers. So let's say if I'm a company, right? And I need to build 10 systems in order to support my businesses. So I used to build 10 systems. I'll have my own data center where I will house the server, where I'll house all the systems. Okay. Earlier that was needed because I needed to make sure that I can control all of that. Okay. But it also brought a whole bunch of other issues, right? The hardware every 3 or 4 years, since they are running constantly, it's going to fail. So I need to bring it the new hardware. The new hardware is going to bring the operating systems and patches and all. So I need to do all those maintenance myself and patching them. To the current world where most of the things like it's Amazon, Google are building what is known as a cloud, Microsoft, right? Where I don't have to build and manage my own infrastructure, my own systems. I can actually log in and just, I said, hey, I want 2 machines. This is the configuration. Identify how the network is going to connect to it. And there is always 2 machines. There's a virtual machines, obviously. But I don't have to worry about replacing hardware every 3 years. Microsoft or Google or Amazon takes care of all of that, right? So the cloud is the essentially platform where you're going to start seeing a lot of applications, moving it from the current platform to one of the cloud platforms as migration. So if I'm writing a project that, hey, I want to move this system from this sets of hardware into the cloud, then that will be a migration project. Okay. And the final set is the data warehousing. Okay. One of the key things that I say that is the most important assets for any of the companies is the data. Right, so I need to make sure I can collect all this data. But data itself, it's not very enriching, right? So I need to mine the data, do a warehousing and analytic on top of it. So one example, right? So I don't know if anyone of you are kind of a fan of any of the social platforms, whether it's a Facebook or Instagram or TikTok or whatever that, right? You see it, there's a lot of data coming in as a user, right? There's a lot of information comes in from various applications, whether I'm doing Facebook messaging, whether I'm going it, putting a like, I'm posting new things, right? All of that data needs to go and correlate it somewhere, needs to make sense of it so that I can give you a feed, right? So like if you go into a LinkedIn or a Facebook, right? A lot of times you get constantly the feed updates, right? Hey, it's based on the connections that you have done. And here are the new connections that are your connections. Do you want to know them? Do you know them? You want to get connected? So all those 9 yards, right? So the data is very important. So you're going to see your projects to essentially build and enhance that data. But then you're also going to see an application that allows you to analyze that data and get the business value out of it. Right? That's why it's so much a big deal when you look into the news nowadays. It's all about data privacy. How much data you're collecting about me and who all you're sharing with it. And what level of detail you're sharing with it. But all of those systems that it builds it, it's all around the data warehouse. Any questions so far on that? All right. So the key thing that you think about is when you're looking into, hey, I need to do it in any one of those projects. Right? From a business point of view, before they build any systems, they are always trying to do it as a problem analysis effort. Right? Essentially, what problem you're trying to solve it when they say, hey, I want to build or enhance the system. You need to step back and say, what problem you're solving, right? So you need to ask the few things when you're trying to do a problem solving. What is the key issue? So in other words, what is the pain point? What exactly is the problem? Like, hey, I'm not able to get more customers, or my performance sucks. What is the actual problem that you're trying to solve? And second thing is, what is the goal that you're trying to do? Hey, I have a performance issue. Great. Well, what should be your performance? What is the goal that you're trying to accomplish? So what is your end state is going to look like? Do you have a good understanding of it? What are the drivers? What are the things which is driving it? So in other words, when they say, hey, it has a performance problem. Yeah, great. What is the problem with the performance? Well, because customers are dropping and going to competitors, so I'm losing all the revenue. Because nobody wants to be where it takes 10 seconds to respond to a query of what is my balance or stock market price or whatever. Right? So you look into it is, yes, you have a problem, you have a goal, but what is the driver? Why do you want to even deal with that issue? What if I don't deal with that issue? What is the impact? Right? What is the cost to me? Okay. And the final thing talks about the scope. Yeah, it's a performance issue. Do you want to try to solve the whole world, or you want to say it's okay, performance issue only for this two functionalities within the system? Let's just focus on that. Right. So the scope, or when you say, hey, I need to build a new system. Well, what all user groups are going to use this new system? Who all you're trying to do? What is the scope? Okay, is it only for internal users or is it for any customers? Right? You can define the boundaries and scopes for it. Okay, so whenever you're trying to identify, hey, there is a problem that needs to be solved. Well, let's just do an analysis. What it makes sense. And the output of this essentially just is it worth solving that problem? Okay. So let me skip that slide. I'll come back here in a moment. Okay. So I know you can't read this. Okay, just bear with me. Think about a project approval process, right? So we talked about, here are the 5 different types of projects. We talked about the problem solving domain, right? And I asked you to skip one slide and we'll come back here in a moment. But let's say I have a problem that I need to solve it, right? So somebody's going to say, great, you want to solve the problem. Let's talk about the actual financial numbers, right? Because at the end of the day, if I'm a business, I'm not there to do the charity, right? I'm there to make a profit. I'm there to make sure my business sustains, right? So any investment that you ask me has to tie with, well, how it's going to benefit me, right? And benefit could be in a multiple dimension. It could be, hey, I'm going to have more revenue, or hey, I'm going to prevent the fines coming in, so I'm going to save the fine. I'm going to improve the overall cost structure. So the benefit could be a multidimensional benefit. But once you said, hey, I have an idea, I want you to fund for it, right? So what they're going to look into it is 3 things. You have a great idea, great. How much is it going to cost to implement that idea, right? So what is the actual money that I have to invest into that idea in order to make it realistic? Second question is going to be how long it's going to take it. Is it going to take 3 months, 6 months, 9 months? How long it's going to take? And third thing is, once it becomes realistic, how much money it's going to generate? Because I invested $1 million. And if said, yeah, you invest $1 million, it's going to give you $500,000 in revenue. And that's it. Would you invest it? If somebody says that, hey, let's just invest this, I have this cool idea, it's going to cost you $1 million to invest. And you say, okay, so what's benefit for me? Well, you get $500,000 out of it. Will you go for that idea? You will not, right? Why would I get less money than what I have? I'm better off by not even investing in it and still keep my $1 million. Right. Another aspect could be is, hey, there are 3 people are competing for your money. So I have $1 million, right? And 3 people are pitching the idea. One person says, hey, it's going to give you $1 million. Other person says it's going to be $2 million. The third one says, yeah, it's going to get a $4 million. Right? You're going to weigh in, right? I'm going to look into it. Which one is going to give me the most profit, right? And that's what I'm going to invest in. So most of the corporations, right, they have a budget. And says, okay, we have only this much money to invest into new ideas, right? And then there are different groups and different teams pitch new different ideas. And then they have to go through this project approval process. It says, okay, how much money you wanted, what is the potential, and how long it's going to take it, right? So whenever you pitch an idea, that's what the 3 pieces of information you collected. And then you go to a group, which is typically a lot of times known as a governance review board, which is made up of business and technologists. And those people review that and make a decision. Is it worth it? Is it technologically feasible? Is it in alignment with what we are looking from both business point of view and a technology point of view? And if so, they essentially go and say, okay, your project is approved. Sometimes they said, you know what, you came with idea. It's great, but I need this additional detail before we can even approve it. So they make you to go redo it. And there may be another path where it's great, but it's not going to give us what we're looking. It doesn't align with our strategic direction. We're not going to use that. So they reject it. Okay. So they, based on that, right? If you make it through it and says your project is approved and you will get the funding, that's when you initiate the project. So that's what happens in the first phase of the planning to do that. Now, when you look into any of the business problems, it essentially falls into one of the 5 domains. Okay. Sometimes you may have multiple domains which influences, but the primary driver is only one domain. Okay. So let me walk you through an example, and then we'll see how each one of them does. So consider a scenario that I'm an owner of bookstore. I have 3 locations and a warehouse in the city. Okay, so that's what I have. So people come to the store, look for the book, and then if they get the book, they purchase it. If they don't have it in one, they go to the second one, then they go to the third one, and then warehouse, and then they decide I don't have it. So consider that scenario. Okay. For a moment, don't think that I have any systems, right? Let's keep the software systems apart. Just let's do a pure business process. Okay. So let's say I have a pile of books. Okay. Let's say it's not organized. It just says, hey, as I get it, I dump the boxes and that. So whenever a customer comes in, says, hey, do you have this book? I have to go through entire pile to find it if I have a book or not, which typically takes me 8 hours to go through it. Okay. And then I tell them, hey, you know what? I don't have a book, but we have another store. Why don't you go check there? So customer goes to that store, same process, and takes another 8 hours then to figure out it's not there. Goes to the third store and goes to warehouse, right? So to answer a customer's question, do you have this book or not? It can potentially take up to 32 hours. Good with scenario? Right? So think of that. Now, I have this search that goes 32 hours. That means I have to have somebody doing that search. Right? So I'm paying an employee 32 hours just to find the answer. Now, let's say if I want to improve these things. Okay. Let's say my goal is to say, hey, you know what? It takes me a process, right, where the customer has to go and sequentially to each one of the stores. What if instead of that, I said, let me improve the whole process. Instead of doing everything sequentially, as soon as the customer comes in, I'll have somebody call at all 3 stores and a warehouse and says, can you go find it if you have this book? So now 4 people are like it's doing the same thing together. So my process is improved. I have 4 people doing it. It's not everything sequentially. I can do it from a customer's point of view, right? It's great, right? But it's still going to take me 4 people, 8 hours in every store to do that work. So what if I said, you know what? It's great, but it's not going to work. I want to have productivity improved for my people. Instead of taking them 8 hours, and serving only 1 customer, I want each employee to serve at least 2 customers in a day. That means I need to cut down the time they take it to search for a book from 8 hours to 4 hours. Okay. What if I kind of organize all the books alphabetically? Now it's going to take a less time, right? It helps the productivity, right? Because my goal was not to, can I give a customer faster service? My goal was, can this employee serve 2 customers instead of 1 customer, right? So it is about the productivity of the people. It's not that. That was driving it. Now, the side benefit of it, hey, they found the book quickly and answered the customer quickly. That's great, right? Oh, by the way, that search, By organizing it, also my process of searching improve, right? They don't have to go sequentially. They can just look at it to see if it's in that particular aisle or not, right? So I may have multiple benefits, but the primary driver was, hey, I want to improve my productivity for my employee. The third scenario is a cycle time improvement, right? So to answer a simple yes or no question, originally it took 32 hours, right? Because I have to do all of it. What if I just said, hey, you know what? It takes 32 hours to answer that simple question, do I have this book or not? What if I want to let's reduce that cycle time? I want to reduce that to 1 hour, right? You can do it like it's, hey, either I can call it or I can just check it in my store, doesn't have it, pick up the another store and then do that, right? So customer doesn't have to drive down to the other store and get that and get that information. Even more important, what if I build a system that gives my employee automatically a way to check the inventory on all 4 stores? So they don't even have to call. They can just check it online quickly and then answer the question. Reduces that cycle time for customers significantly. But my driver was, hey, I want to reduce, it takes 32 hours to search to this. And in order to do that, I will do whatever is needed, right? So that's, if I'm doing investment to do that, that's kind of, hey, my business problem is I need to improve something. The fourth one is I need to reduce the cost, right? So think about it, I'm paying all the employees, right? 8 hours each employee. They're paying 32 hours in order to perform just one search. And then each employee is $10 an hour. So it's costing $320 to search if I have a book or not. Right? What if I build a system and it gives me answer in 5 minutes? So now my cost has gone down from $320 to essentially 1/12 of $10, which is less than $1. Right? So my cost has significantly reduced for the searching. If that is the driver, then I'm doing it, then hey, I'm not interested in cycle time. I want to reduce the cost to be less than $1. And in order to do that, all these things are benefiting also. That's a different thing. But my primary reason why I made an investment is I want to reduce the cost. And the final one is need to improve the market share. Okay. So let's say if I'm kind of a mom and pop store, right, that we talked about. I want to want to have my market improve from just the current city where my physically all stores are located to anybody in the state, right? So I can just say, hey, you know what? I'm going to advertise and say, hey, you can order the books by phone. So if you call it over the phone, we'll tell you whether it's there or not. We'll take your money, we'll pack it, and we'll ship it to you. Now, all of a sudden, my market increased it from the local city to anybody who can phone call. And I can just say, hey, we can ship you within the United States, lower 48 states. It's great, fine, right? So now I expanded the market to that. Or if I said, hey, I want to be anybody who can order from anywhere. I want it on the web. Now I expanded the market share significantly, right? So originally it was only let's say 50,000 people live in my city. That was the only potential population. But now with this, I can expand and reach everybody in the country. So that's my market share improvement. Okay. Make sense?
Yeah.
Okay. So what I'm going to do. Okay. So if you flip into your folder, right after the first tab, you will see this thing called custom creations, the first page. You can see it? Okay. So if you flip it, the marker, that's what this is. Here's what I want you to do. I just talked you through scenarios where, hey, which will be the 5 key drivers for business, right? So we just talked only about this things, business problem identification. Okay, and says, here are one of the 5 reasons behind that business problem. Okay, so I want you to read it, this particular business problem, right? So this is a business problem. And I want you to, like it's put together and says, okay, after reading, what is your interpretation? Which one of this 5 is the primary driver for writing that business problem? Okay. You guys with me?
Yeah.
Everybody clear what needs to be done? Okay, I'm going to give you 10 minutes to read through it and decide which one you want to do it, and then we'll talk through it. Okay, so Pooja, did you get that?
Yep, all clear.
All right, you're all good? All right. So take a look at it, read through it, read it carefully and say it's which one is going to be the primary reason.
If I can't find the.
You don't have
No.
So it's 12:15 and this clock will go till 12:25.
Yeah, yeah.
Sorry, I was doing it right. Okay, you good with that, Pooja?
Yeah, all good.
Okay. How many of you think it is productivity improvement? So Oliver thinks is that. You also think it's productive, the primary driver, right? There could be
Or the
multiple.
primary.
Which one is the primary?
It can be productivity improvement, yes, because
Okay, so you think it's also primary driver? So I'm going to just put 2 of you. How many of you think it's a cycle time improvement? Okay. What about cost
I-
reduction?
I'm
Go
actually
ahead.
confused between process and cycle. So, there
Which
are
one you-
chances-
Which one you think is primary, Pooja? Pick one that you think it is most one.
I think process.
Okay, so you say it's a process. Okay. All right. So when you say you're the only one who's left, what do you think is the primary?
Process.
You think it's a process? All right. So as a class, we feel it's either process or productivity improvement, right? So Pooja, yourself, Vanessa, Cynthia, why do you feel it's process improvement? Let's go to the description. What makes you think when you read this that it is process improvement?
Because it's stated in the, it said currently, they manually track all the orders, work they send to third-party vendors, and would like a better way to manage their overall order and fulfillment process.
So this is the reason where you think it is process improvement.
Yeah.
What about you, Vanessa?
Also that, but for me, they need to improve a lot of like even the shipping. But if you ask me about only one thing, I'm gonna say.
What are the other things? Let's talk through it. Like, which are the other things? Let's just identify. You think there are multiple opportunities, that's process improvement.
Yes, for they need improvement in for cycle time,
But that's a cycle time improvement. It's not process improvement.
Yeah,
That's a different, remember, cycle time is different than the process improvement.
And I want to add to it, and like all the list they listed to the end of the case, it's like I see all those as how to start like processing their,
Okay,
they
like
want
to
to
show all
improve,
the work.
and they want to improve.
what additional improve, right? You can't just do general. What is in the description that caught your attention to think about it's a process improvement?
That sentence to support this claim management has decided, develop a system. No,
That's a process improvement?
no, the better way to manage their overall order.
Where is it?
It was when we talk about the third party.
Yeah, that's what I highlighted,
Yeah.
right? So that's already I highlighted.
Mhm.
That's, do you think it's primary? Pooja, why do you think it's a process improvement?
So one, there are many things. One is they already, so they know that they are in the range of 1 to 3 weeks as of now, which they want to bring it down to 1 week and then 2 weeks. Sorry, same day and then 2 weeks. So that's a clear indication that they want to make some changes in the process, maybe.
But that's a cycle time improvement, right? They're not saying that I want to improve a process. What they're saying is, hey, I want to improve the cycle time from 1 to 3 weeks down to a single day. Right?
So, but the cycle.
How I
time-
do could be the process. But the driver is cycle time in that case, if I read that description.
Okay, and then there were some other things mentioned about the website that they currently have. They want some changes there. They want people to be able to upload images and track everything. And then they want to set up different criteria. So all of this was kind of an indication to me that they want to change something in the way that they're functioning right now.
Okay, so you think
this-
it's that, and well as the three that thing I highlighted are the primary driver
Yes.
process improvement, okay? So Oliver, you and Geeta say different opinion, that's
I just
productivity
thought that,
improvement.
I mean, currently customer creations have a website that provides their customer, I mean, it can increase the productivity if they have more customers on that, so.
Wait, hang on, so productivity of whose? So remember, productivity is you have to do it from the customer creation point of view, not the customer. So what made you think that, Oliver? Tell me the items here, so I can highlight.
Okay, so it's currently customs creation hub, a website that provides their customers ability to see type of products they can customize for their orders.
Mhm.
So looking at that, it means they need the productivity to improve.
So what, tell me the numbers, like what productivity they're seeing. What is the current productivity and what is the new productivity that they're looking for to improve?
So when you come to the next paragraph, say depending on the product.
Yeah, but that's based on a type of product that I use it,
Right.
right? But it doesn't say that, hey, my employee is able to handle 5 customers and I want them to do it 10 now. Right? It never says any of that.
But it says like between 1 to 3 weeks.
But that's a time, cycle time. That's not productive. Think of it, I'm an employee, I'm handling all the customers that come into this customer creation. And if you focus on productivity improvement, what it tells it that, hey, I was able to handle 5 customers in a day before. Now you want me to change it to so that I can handle 10 customers. Right.
बहुत अच्छी है। कटरीना और शाम कई फिल्मों में साथ काम भी कर चुके हैं। इनमें फैंटम से लेकर टाइगर जिंदा है तक शामिल है। फिलहाल लोगों को कटरीना और उनके परिवार की
Have something on?
आप क्या कहेंगे इस पर? हमें अपना कमेंट दे दीजिए। बहुत जरूर।
Okay. So you see, Oliver, what I'm saying,
Yes.
right? Where in the document you got that interpretation? Because it never says how many customers I serve or what is the productivity. All it talks about is the cycle time, right? That, hey, it takes it 1 to 3 weeks to complete the order, which I want to change it to so that I can get it in the same day service. So instead of like it's taking 2 weeks or 3 weeks, I want to get it done in a 1 day. Right? It doesn't say how many customers resolve. All it just says that for my customer's point of view, I got this order, or it takes me 3 weeks to complete it and get the money. I want to change that to 1 week or 1 day and get the money right away. Right? So it's definitely based on that definition, it's definitely not a productivity improvement. Right? Do you agree, Geeta? Okay. So I want you guys to think about this one. Do you feel that there are multiple things into it? I think you pointed out, and I think Pooja pointed out, hey, it's a cycle time as well as the process improvement. Do you guys feel it that there are more than that? What all are there? So you say that like it's, hey, there is a process improvement that you feel.
They also want to improve the market share because they want to start taking order from corporations.
Ah. Okay. So why didn't you say that before? Why didn't you think that it was before?
No, for me, when I was reading that, I put a lot of problem like market share, cycle time.
But which
for
one's the
this-
primary one?
Yeah. market
So
share.
like it's now, you guys narrow it down to say, hey, there's 3,
Mhm.
we eliminate the productivity. Is there a cost factor in it?
Mm.
No, no cost factor? Everybody agree with Vanessa? Right? So it's one of these 3 is the primary. Agree?
Yes.
So think of this one, if one of these things, where is they're putting the focus? So read carefully. For upcoming season, their management decided to start taking orders from corporations to customize employee gifts and that. Okay, so all it just tells you, hey, here are all the problems I have. It's good to know that I have other problems, but my current priority is taking this. So yeah, it's great that I have identified I have a process improvement problem, I have cycle time improvement problem. But that's not driving me to focus on my effort next year. What it's driving me is I wanted to take the order from corporations to customize, right? Because that's a big money and big area instead of individual that. So this is what is my primary driver, right? Because they talked about a whole bunch of things here. This are my wish, but they didn't tell it that this is where I'm putting the money. The one where I'm putting the money is where I want the corporations to get it, right? So this is that, so the management has decided. So this is where they're putting the money.
The first one is market share.
This is the market share, right? I'm trying to get the market share. While doing this, if I can get any one of this, it's great, but I'm listing out here are my problems. But I'm not focused on solving that, I'm focused on solving this. Okay, so here's a couple of things I want you guys to notice from this exercise, right? One is definitely you're gonna have multiple things. So you have to drive it down to what is the primary thing. The other one is other benefits that I will get it when I do this. But more importantly, there are 5 people in the class who read this. There was a different interpretation by each one of them. Okay. So as a business analyst, you're going to talk to different users. you need to make sure your interpretation is exact same for each one of them. Right. And if you don't know, it's okay to ask the question. You're going to use the different techniques to figure it out. What is driving it? Right. So a lot of times it may be easy. Hey, here's the list of requirements they send me. Let me just make sure I understand that. You have to read it carefully. Make sure you're able to interpret it the right way. Okay. You guys good?
Yeah.
Okay. Any questions? Pooja, you have any questions online?
No questions, but I'm just wondering that why is it that we always have to focus or come down to only that one primary thing? Why can't we have, let's say, two equal problems?
So this is classic business problem. Like it's when you try to focus on too many things, you don't focus on anything.
Okay.
So whenever you sit down, and I've been into multiple governance review boards, when you sit down, right, you ask the questions to figure it out. What is the primary motive? What is the one thing that you want to accomplish?
Mhm.
And part of it is also you drill it down. Okay, if you want to accomplish that one thing, are you successful? How are you going to measure it that you are successful in that? Because all the business runs it is at the end of the day, it's in the dollar and cents. And all the process improvement and everything runs based on, can you show it how the needle is moving, why the needle is moving, and how much the needle will move? Right?
Good, yeah.
So in order to solve that problem, right, you may have to do multiple effort, and the combined effort is going to be, right? So in this case, right, when I look at that, right, the question that I ask it is, okay, you want the cycle time to go down from 1 to 3 weeks to 1 day, right? Is that going to help me to increase my corporate customers, which are currently 0? And if the answer is no, yeah, it's a nice thing to have it.
True, yeah.
I can get the corporate customers, and then if I can get the corporate customers and turnaround days becomes 2 days, then I can look at, oh, there's already an improved process. Can I apply that to the front end customers too? Right?
Makes sense, yeah.
So you have to look at it. What is the primary thing which is driving me? Because they said, hey, you know what? I'm still okay with 1 to 3 weeks. But instead of getting only order from 10 customer, now if I get it from 50 customer, as long as I'm still able to maintain 1 to 3 weeks, now I have more revenue coming in, I have more profit coming in. And that's what my goal is.
Okay.
It's good?
Yeah, all good.
All right. We already talked about it. So here is what I want you to do it. Okay. So the way we're going to run this workshop is we're going to continue to drill it down more in customer creations as we go through the examples, as you read through it. Okay. But there is also another case study in your folder, okay, which is around the health system. Okay. Let me see. Hold it. So if you look into it, there is a second set of proposal for you. It is called the PHN nursing proposal. Okay. What I want you to do it as a homework for today. You need to read it before tomorrow's class. I want you guys to read the proposal. Okay. And when you read the proposal, I want you to think about, is what is the purpose for floating that proposal? What is the primary reason why that proposal was given? Okay. What type of system development it is? Remember, like 5 categories we talked about: new, enhancement, rewrite, migration, and data warehouse. I want you to tell it, based on this proposal, what kind of system work that they're expecting us to do? Are they wanting us to write a new system? They want us to rewrite it? What exactly they want us to do? Okay. And third thing I want you to do it is identifying the type of the business problem they're trying to address. So we just did that exercise for custom creation, right? What type of the business problem they're trying to address? It was a market shift, right? So when you read this, I want you to figure out what type of this things they're going to do. So your homework between now and today and tomorrow morning is read through it. I think it's only like, it's about 12 pages.
You said a mental
So
center?
which page is that? I'm sorry.
It is this whole proposal. Right, so,
Oh,
yeah, so this is the whole proposal, right? This has some additional documents if you want to read
so
through.
from here, you know, from-
Yeah, from here to here, right? So this is the main proposal. Okay. So, Pooja Online, this document is the main proposal. All the
Yeah.
other one is supplemental document. So you read through this 11 pages and trying to answer that 3 questions. Okay? That's all to do it. So, yeah, show that graph. Yeah, so this one. You read this one. Okay? Tell the graphics. Yeah, so this entire thing. Keep reading it. Tell you this. Okay. Now you can read the other stuff and answer this 3 question, which is on your slide, right? If you look into your PowerPoint, slide number 17 or 37, you should see it.
17 or 37?
37, this one.
Okay,
So if you look into the slide, which is right after
page
that.
19. Page 19. Page 19, slide 37.
It's right about the module 2 slide. Okay. Those are the 3 questions you want to answer. So we will start tomorrow morning with the discussion of here, this one. Okay. What is the purpose of the proposal? What type of system development, right? Out of the 5 categories, and which one is the primary business problem they're trying to solve it out of the 5 categories?
Is it the one you said 37, is it the types of software architecture?
No. Page 17.
It should be 19.
Yeah, we are solving this, but.
So the last one.
Doing those, answer those 3 questions. Read that
Okay.
things and answer those 3
So you
questions.
said the last one is,
Ours is different because it's only 1 page per slide. Yours is 2 pages per slide. So that's. Okay. Everybody clear
Yes.
what you need to do?
Yes.
Okay. It's good. And we are ready to call it a day. You read through it and then we will have that conversation first thing in the morning. And we start 9 o'clock. So you try to be here by 8:45 or 8:50. So we want to get started on time. Okay. All good. Just wrapping it up.